Hi everyone. So in the last lecture we were done with our rectangular waveguide. We have seen all the field equation, waveguide parameters, power calculation, field patterns and assignment also we have seen. Now we need to start circular waveguide. So in circular waveguide as well we need to study the ditto same things. Just the equations will be different, analysis will be a bit different. So if you have studied rectangular waveguide, it will be a cake walk for you. Right? So in rectangular waveguide what did we study? That our cross section was rectangular. This cross section was rectangular and it was like a cubic box, or you can say it was a box like a matchbox. So here there was conducting plate, here there were conducting plate, but z coordinates were open, right? Here what did you assume? That the material is perfect dielectric. Inside the material is perfect dielectric. That means sigma is equals to 0 and rho v is equals to 0, and the plates are perfect conducting. The same thing is here in circular waveguide. What will happen? Circular waveguide is something like this water bottle. Okay, so it is a cylindrical structure, but this end of water bottle and this end of water bottle is open. Are you getting this point? In our rectangular waveguide, this was a matchbox. 1 plate, 2 plate, 3 plate, 4 plate, and this end was open. Similarly here, this is our cylinder. This is our cylinder. So from this end the wave will come in. So this end is open, and from here the wave will go out. So this end is also open. In rectangular waveguide, which coordinate system did we use? We used x, y, z, right? In a rectangular waveguide, we used x, y, z coordinate system. So this we assumed as our x, this was our y, and this we assumed as our z coordinate system. X, y, and z. Here in cylindrical coordinate system, what we will use? Rho, phi, and z, right? So where will be your rho? Your rho will be in this direction, right? Rho is always along the radius. Where will be your phi? Phi is always along the perimeter. And where will be your z? This will be your z. Or you can say like this z is going in this direction. So the diagram will not be that perfect. So to make the diagram perfect, what we can do is that, like, you are able to understand this structure, right? This water bottle is set something like this. So from here the wave would come and it will travel. So rho, phi, z coordinate will be there and all are perpendicular to each other. So rho is always along the radius. So this is your rho. So limit of rho will go from 0 to a. I am assuming the radius is a. What I am assuming? The radius is equals to a. Here the limit of x was going from 0 to a. Limit of y was going from 0 to b. And z limit we did not define. Here rho will go from 0 to a. Phi will go from 0 to 2 pi. Because phi will be a complete circle 0 to 2 pi. And z limit we will not define. Because our wave will be propagating in z direction. So same thing will happen here. Wave will come here. Wave will come into the waveguide. If it walks along rho, it will get standing wave pattern. If it walks along phi, it will get standing wave pattern because there are conducting plate. So here also sigma is equals to infinity. So all these are conducting plate. This plate, all these structure are conducting plate. Here this end is open, this end is open. So all these are conducting plates. So wave would come, it will strike to the conducting plate, it will make standing wave pattern. But if it goes in z direction, then it will be a traveling wave. So in the direction of r, in the direction of phi, it will be a standing wave, but in the direction of z, it will be a traveling wave. Why is that so? Because in z direction it is open and it can travel in the z direction. Same thing was happening in our rectangular waveguide. In the direction of y, standing wave, in the direction of x, standing wave, but in the direction of z, it was propagating because z side was open, so it can propagate there, right? So same thing will happen there. Here in the direction of r, in the direction of phi, it will be a standing wave, but in the direction of z, the wave will propagate. So this is our circular waveguide, and inside the material inside it, because this will be a hollow structure, so the material inside is perfect dielectric. Perfect dielectric means sigma is equals to 0 and rho v is also equals to 0. There is no charge density and there is no conductivity. So material is perfect dielectric. Is that clear to you? All these things are clear. So I hope you must have understood the meaning of circular waveguide. So it is simply a cylindrical structure, hollow cylindrical structure, where the cross section is circular. Why it is known as circular? Because cross section is circular. Why it was known as rectangular? Because cross section was rectangular. So from here the wave would come and it will travel along z direction. It is having a radius of a. The radius is a. So how we will define the coordinates? We will define the coordinates in terms of rho we will define the coordinates in terms of rho, phi and z. Rho value will change from 0 to a, phi value will change from 0 to 2 pi, and z value we do not define. Similarly, here as well we did the same thing. Now to understand circular waveguide, you need to understand Bessel's function. Okay. Here there was no other function. Here was nothing introduced. Here the function, here EZS and HZS were simply a function of cos x sin y. Sorry, cos x, EZ was a function of Isha is sweet, so sin x sin y, and HZ was a function of cos x cos y. Similarly, EX was a function of cos x sin y. So cos function you already know, sin function you already know, but here your EZ will be a function of a Bessel's function. It will be a function of Bessel function, which is denoted by Jn. So you do not know about this Bessel function. In engineering mathematics you might have studied, but this is my job to teach you again. So now we are going to study about Bessel's function. So first we will study about Bessel's functions, then we will again come back to circular waveguide, because understanding Bessel's function is very important, otherwise you will not be able to understand circular waveguide at all. So let's start studying about Bessel's function, but first let's plot a simple function, any random function we are plotting. The function is x square minus 1. So I am asking you to plot this function, fx versus x you need to plot. What you need to plot? Fx versus x. So try doing it on your own. This much simple mathematics you should know, right? So here you can see that at plus minus 1 we will get 0 value, minus 1 and plus 1, and here if I do the differentiation, what I am getting, f dash x is equals to 2x. So from here x is equals to 0. So this is the location of your minima, because at x equals to 0 you are getting minus 1. Yeah, so this is the location of your minima. So how will the graph go? So the graph will be something like this. So any function, if the function is a function of x, there is a function of x, so you can plot fx versus x any day, right? Also there is a term defined, zeros of fx, zeros of fx. If I ask you what are the zeros of fx, what you will say? When the function becomes 0, at what value of x the function becomes 0, that is defined as zeros of fx. So 0 of fx are x equals to 1 and x equals to minus 1. Say yes or no? This is simple mathematics. We already know what is a function. Function is x square minus 1. It is a function of x. So we plotted it and we got to know when it is having 0 value. So zeros of fx is defined as the value of x at which it is becoming 0. Now let's start studying about Bessel's function. So Bessel's function is denoted by j and x. Similarly, this function was denoted by fx. So Bessel's function are denoted by j and x. It is denoted by n and x as well. So there are a lot of Bessel function. Bessel function of first kind, Bessel function of second kind, Bessel function of third kind as well. But you need to study about Bessel's function of first kind only. You do not need to study about this. So whenever I say Bessel's function, you only need to think about Bessel's function of first kind. That's it. I am again repeating it. You only need to study about Bessel's function of first kind. So if I am saying Bessel's function, then only you need to think about j and x. Now, what is j and x equivalent to, that we don't know. In this problem, our fx was equivalent to x square minus 1. But what is j and x equivalent to, that we don't know. But we know the graph of j and x versus x. Here also we know the graph of fx versus x, right? Here also we know the graph of fx versus x. Similarly, here we know the graph of j and x versus x. Where what is your n? N is known as what is your n? N is known as order of Bessel's function. So with respect to different values of n, you can plot j and x versus x. What do I mean to say is that this is for n equals to 0. This is for n equals to 0. That means if you put n equals to 0, so the graph of j naught x versus x will look something like this. Are you getting this point? And if you put n equals to 1, then graph of J1x versus x will look something like this. So J0 x versus x is denoted by blue, and J1x versus x is denoted by green. Now what you need to study from this graph? So only the thing that is required for you is zeros. So when are you getting Jn x equals to 0? So for n equals to 0, we are only seeing at J0 x graph. So this is our J0 x graph, right? This is our J0 x graph. This is our J0 x graph. So when this graph is becoming 0 for the first time at 2.403, then it is becoming 0 again here, then it is becoming 0 again here, then it is becoming 0 again here. So it is becoming 0 for multiple times. So it is having multiple zeros. What is the first 0? The first 0 is 2.403. Similarly, for J1x as well, when n is equals to 1, for J1x as well, you can see the same thing. Now you need to look at this graph. You don't need to mug up this graph, okay? If question is coming, then graph will be given. So what you need to check, how much time it is becoming 0. Like it is becoming 0 for infinite time, but you need to check the location. So at value of x, which is 3.382, it is becoming 0 for the first time. You will not say that, sir, here it is also becoming 0. No, ignore this. Okay, this is the 0 for the first time. Then again it is becoming 0 here. 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 For n equals to 2, there will be different graph, J2x versus x. But that graph we did not draw it. There would be also different graph. That different graph will go in a different manner. It will also have its own zeros, right? So let's write down a few things about this graph, because understanding the Bessel function graph is very, very important for you. So what we are writing, we are seeing when j and x is becoming 0. When j and x is becoming 0. So for n equals to 0, for n equals to 0, for n equals to 0 at x equals to 2.403, for n equals to 0 at x equals to 2.403, it is becoming 0 for the first time. J0x is J0x equals to 0 for first time. Say yes or no? Now for n equals to 0, for n equals to 0 at x equals to 5.52, you need to see this curve, n equals to 0. For n equals to 0 at x equals to 5.52, it is again becoming 0. First it became 0 as 2.403. Now at 5.52 it again became 0. Now here also it will again become 0. It is something around 8, or you can say it is something around 9. Then again it will become 0. It is something around 11. Then again it will become 0. It is around 15 only. Then again it will become 0. It is around 18. So this is the first time it is becoming 0. This is the second time it is becoming 0. This is the third time it is becoming 0. This will be the fourth time it is becoming 0. For n equals to 0. Are you getting this point? For n equals to 0, the Bessel's function is becoming 0 for the first time at 2.403. It is becoming 0 for the second time at 5.52. It is becoming 0 for the third time as at something about 9. Some value would be there that we don't care. So are you getting this point, what we are doing here? And why we are doing so, you will understand. Do not worry about it. So at 5.52, it is becoming 0 for the second time. So J0x is equals to 0 for second time. Same goes for J1x as well. So here J1x is becoming 0. J1x is becoming 0 for first time. Why is that so? For n equals to 1. For n equals to 1, that means which graph you need to check? This graph you need to check. For n equals to 1, this graph you need to check. So if you check this graph, then when the function is becoming 0 for the first time at 3.382, then again it will become 0. This graph you need to check. Then again it will become 0 here. 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 So this is the 0 for the first time. This is the 0 for the second time. This is the 0 for the third time. This is the 0 for the fourth time. This is the 0 for the fifth time. So that we are writing down. So for n equals to 1, for n equals to 1, what is the first time you are getting your function to be 0? That is 3.382. Now, what is the second time it is becoming 0? That is roughly around 7 only. So, it is 7.73. 7.01 actually. It is 7.01. So, for n equals to 1, j1x is equals to 0 for second time. So, now what I am writing is that your jnx is equals to 0 at x equals to xnp. What did I say? My jnx is equals to 0 for x equals to xnp. What do I mean by that? Let's just say I have written x11. What does that mean? That for n equals to 1, because the value of, if I have written x11, that means the value of n is 1 and the value of p is 1. So what I am saying is that for n equals to 1, that means n equals to 1 I will put here. For n equals to 1, at what value of x? At what value of x? For n equals to 1, at what value of x? N is 1, so that's why I am writing jnx is becoming 0. For the first time. Here I could have written x12 as well. What does that mean? For n equals to 1, j1, for n equals to 1, at what value of x? j1x is becoming 0 for the second time. Are you getting this point? What is the meaning of x and p? People will study complete circular waveguide, but they will never understand the actual meaning of x and p. So what is the meaning of x and p? I said that I need to find the zeros of jnx. What I need to find? Zeros of jnx. So for that, what I need to do? When I need to find the zeros of fx, what did I do? I put fx equals to 0. If I need to find the zeros of fx, so what I need to do? I need to put fx equals to 0. If I put fx equals to 0, that means x square minus 1 is equals to 0. So from there you get this value. So now if I need to find zeros of jnx, what I will do? I will put jnx equals to 0. Here I put fx equals to 0, then x value I got. Then from here I got the values of x, that is plus minus 1. Similarly, here as well I will get the value of x, and that value I am denoting as x and p, because I know that j and x will be 0 for multiple time. It will be 0 for first time, then second time, then third time, fourth time, fifth time. Now n value can also change. N value can also be 0, 1, 2, 3. So that's why I am denoting x as x and p. So what does this x and p represent? So for example, I am saying that x11, that means n is 1 and p is 1. So for n equals to 1, at what value of x? j1x is becoming 0 for the first time. For first time. So x11 value is what will be the what will be x11 value? So for n equals to 1, j1x is 0 for the first time. At what value of x? 3.382. So x11 value is 3.382. Now let me know this thing, x02. Let me know the value of x02. What will be the value of x02? Here, what is the value of n? For n equals to 0, at what value of x? Or at what value of x? j0x is equals to 0. j0x equals to 0 for second time. For second time. Say yes or no. Did you understand the meaning? Did you understand the meaning of x and p? So what will be the value of x02? x02. What will be the value of x02? So for n equals to 0, j0x is becoming 0 for the second time. So x02 will be 5.52. No need to remember these values. These values will be given in your examination. Okay. If you need to remember any value, then you can try remembering this value. That for n equals to 0, What is the minimum value of n? What could be the minimum value of n? 0 only, because n value can be going from 0, 1, 2 in this manner. What about p values? What about p values? Can p value be 0? No, because there is no meaning that jnx is becoming 0 for the 0th time. Let's just say I say I am coming into this room for 0th time. No, this sometimes doesn't make any sense. If I am coming in the room, that means I am coming in the room for the first time. I can come in the room for first time or second time, third time. What do you mean by 0th time? So jnx is becoming 0. Either it will become 0 for the first time. No, let's just say there is a random function. So this is becoming 0 first time, second time, third time. So p can never be 0, right? So p can never be 0. So this is also important point. People will understand complete circular waveguide, but they will never know why p cannot be 0, because they don't even know the meaning of x and p. So that is very important. That's why I am spending a lot of time here. We can study circular waveguide in the whole lecture, but understanding Bessel function is very important, because what I feel is that if they are framing a question from circular waveguide, then they will give this graph. Rather than giving any table, they will give this graph, and they will test whether you know about Bessel functions or not, whether you know how to read the Bessel functions or not. So you should understand reading the Bessel function. So I hope you are getting what we are finding. We are finding the zeros of jnx. N value could be different. Now the 0 you are getting at different values. You can get zeros at first time as well, second time as well, third time as well. So at different values of x, you are getting different zeros of at different values of x, you are getting zeros of jnx, and n values can also be different. So that's why I told that when jnx is equals to 0, at that time your x is equals to x and p. Okay, what does that mean? That means that what does this mean? This means that jn, x and p will always be equals to 0, because if you put x equals to x and p, you will get 0 only. So p value can never be 0. So what will be the value of p? P could be 1, 2, 3, 4, anything. So this can also go from 1 to infinity. This can also go from 1 to infinity. You can remember this thing, that what is the minimum value of n? 0. What is the minimum value of p? 1. So for n equals to 0, at what value of x? For n equals to 0, at what value of x? J0x is becoming 0 for the first time. Can I say it in? Can I say the same sentence in other manner? For n equals to 0, for n equals to 0, at what value of x you get the first 0 of j and x, or you can say j0x. For n equals to 0, at what value of x you get the first 0 of j0x. What do you mean by 0? 0 means j0x has to be equals to 0. So this could be the other way of saying it. There could be third way of saying it. What is that? For n equals to 0, for n equals to 0, at what value of x you get the first root of j0x. Root. Do you know the meaning of root? Here we wrote that these are the zeros of fx. So zeros of fx can be written in the same manner. Roots of fx equals to 0. These things we have studied in elementary classes, but we forget all these kind of things. That's why I took this function. Do you know there are two terms, zeros of fx, zeros of fx, zeros of fx. It is equivalent to roots of fx equals to 0. It is equivalent to roots of fx equals to 0. Say yes or no. So what did I say? If I need to read this line, how will I read this line? For n equals to 0, for n equals to 0, at what value of x you get the first root of j0x equals to 0? Or how I can read it? For n equals to 0, at what value of x you get the first 0 of j0x? Or how I can read it? At what value of x for n equals to 0 you get j0x equals to 0 for the first time. So this is the basic definition, very basic definition. Then you can write the definition in terms of zeros or in terms of root. So shall we write it down? Yes, we should write it down. So x and p is equals to x1, 2. Let's just say x12. So how will you define it? For n equals to 1, at what value of x you get j1x, we can say j1x equals to 0 for the second time. Or this is the first way, or for n equals to 1, at what value of x you get the second root of j1x equals to 0. Or what could be the other way? For n equals to 1, at what value of x you get the second 0 of j1x, 0 of j1x. So this is what I feel. This is what I feel. They give these kind of language in the examination. Rather than giving any table or anything like that, they will give these kind of languages, or they will make the graph. And then they will ask question on circular waveguide. What people usually remember is this table. They will think that this table would be coming. It might happen that this table can also come, but my intuition says that they will write down these definitions, because you should be clear with the definitions. Here, what will happen? What is this table? This table is zeros of j and x, or this is the table of x equals to x and p. That means from here, what people usually do is that they will put the value of n equals to 1, and they will put the value of p equals to 1. So what is the value of x11? So n equals to 1 and p equals to 1. So this value is 3.832. So this is very easy. But if they write down in the language, then it would be difficult. So if they have written down in the language, then those people who have studied thoroughly about Bessel function, then only those people will be able to answer, right? So let's see one more thing. So j&x is equals to 0 at x equals to x and p. So what you can call this x and p as? So x and p is the pth 0 of j and x. Say yes or no? pth 0 of j and x. Just relate this line with this statement. These two statements are same. These two statements are ditto same. pth 0 of j and x. For n equals to any value, for n equals to some n, at what value of x you get the pth 0 of j and x. So x and p is the pth 0 of j and x. Okay, so this is the definition of x and p, pth 0 of j and x. Or you can say pth root of j and x equals to 0. Pth root of j and x equals to 0. Say yes or no? So this we have understood. Now this is the table. From here you can get any values, like x. If I ask you what is the value of x22, then what do you understand? At what value of x for n equals to 2, j2x is becoming 0 for the second time. For the second time. So 2, this value 8.417. So from this table, if I ask you what is the value of x22, what is the value of x22? 8.417. If I ask you what is the value of x13, so for n equals to 1, at what value of x j1x is becoming 0 for the third time? So 1, 3, so 10.174. And what value I am asking you to remember from this particular graph? Which value I am asking you to remember? 2.405. That means for n equals to 0, what is the first time your graph is becoming, your J0x is becoming 0, that is 2.405. Because this is the minimum value of all of them, no? 2.405 is minimum. This 5.502 is larger, 8.654 is larger than 2.405. This is also larger. This is the minimum value, no? So minimum value I am asking you to remember. Why I am asking you to remember, you will understand it. Later on in this video only you will understand it. So only this value I am asking you to remember. Rest all will be given in the examination in the form of language or in the form of graph or in the form of table as well. Right? Now let's see the differentiation of Bessel's function. So differentiation, simple differentiation. What is the differentiation of fx? F dash x. So what will be the differentiation of Jn x? That would be Jn dash x, right? That's it. Now what could be the value of n? N could be 0, 1, 2, anything. So now this can also be 0, like Jn dash x. Now we will draw the graph of Jn dash x. We have drawn the graph of Jn x. We have drawn the graph of Jn x. Now we will draw the graph of Jn dash x. So this can also be 0, no? At different point. What I mean to say is that Jn dash x can also be 0 at a different value of x. So that we will denote as x dash np. What does this x dash np represent? This is the pth 0 of Jn dash x. Basically, when Jn x was 0, then x was equals to x np. But now when Jn dash x is 0, then x is equals to x dash np. We can also denote it using x np as well. But here we have denoted it using x np, no? So why to use the same term? So that's why I am using x dash np. So when I have written x dash np, what does that mean? That at what value of x for n equals to n, Jn dash x is becoming 0 for the pth time. Are you getting this point? If I have written x dash 2, 1. So what does that mean? For n equals to 2, at what value of x, J2 dash x is becoming 0 for the first time. Are you able to read it? Right? You should be able to read it. Now we have spent enough time. We are spending 30 minutes on this particular topic only. So this is the graph of derivation of Bessel's function. You don't need to mug it up. This is for n equals to 1. And this is for n equals to 0. Now from this graph, if I ask you what is the value of, we have only written first and first only. So let me ask you, what is the value of x dash 0, 1? So how will you read? How will you read? For n equals to 0. So first I need to look at this graph only. For n equals to 0. For n equals to 0, at what value of x, J0x, J0 dash x is becoming 0 for the first time. So for the first time, it is becoming 0 at 3.832. Say yes or no. And if I ask you x dash 1, 1, what do you mean by that? For n equals to 1, that means I need to look at this graph. For n equals to 1. So for n equals to 1, at what value of x, J1 dash x is becoming 0 for the first time. So 1.841. 1.841. I am asking you to remember this value, because this will be the minimum value in the next table. So this is our new table. Similarly, we draw the table for this guy, no? Here also we have drawn the table for this Jn dash x. So Jn dash x can also be 0 at x equals to x dash np. What is this? X dash np. What is this x dash np? This is the pth 0 of Jn dash x, or you can say pth root of Jn dash x equals to 0. Okay, so from this table, if I ask you the value of x dash 2, 2, what that would be? So at n equals to 2, at what value of x, Jn dash x, or you can say J2 dash x is becoming 0 for the second time. So 6.706. Okay, so these things are there. Which value I am asking you to remember? This value. So which value? For n equals to 1, at what value of x j1 dash x is becoming 0 for the first time? That is 1.841. Why I am asking you to remember, you will understand. So this value I am asking you to remember here. So for x dash case, we are taking n equals to 1, and for xnp case, here the case was x dash np, and here the case is xnp. So for xnp case, we are taking n equals to 0. N equals to 0, 0 is becoming for the first time. N equals to 0, but for the first time. Here n equals to 1, but for the first time only. So here n equals to 1 and p equals to 1. But in the previous case, n equals to 0 and p equals to 1. Okay, so two values I am asking you to remember. Eventually you are going to remember it because we are going to use it again and again. So now we are going to start the circular waveguide. Now it will be cakewalk for you. If you have understood the previous 35 minutes of the discussion, then everything will be a cakewalk for you. Just the equations we are going to write down in the same manner that we studied in our rectangular waveguide. So I will take a break because of the cough. ठीक है, अभी मेरे को खांसना है काफी. So that break I will take, and you also revise the previous part and then come back to the circular waveguide chapter. Okay, yeah. So let's start a circular waveguide now. Okay. So now EZS and HZS expression we can write. What we did in our rectangular waveguide. In rectangular waveguide, we saw that your E field would be EXS AX cap plus EYS AY cap plus EZS AZ cap. Similarly, your H field would be, here also the same things are there. HXS HYS plus HZS AZ cap. And what did we assume at direction of propagation? Direction of propagation. What will be the direction of propagation? So direction of propagation is plus Z. This is what we assumed as direction of propagation because this is our waveguide. So this is our rho, this is our phi, and Z will be along this. So in Z we have open space, so it will travel along the Z. So direction of propagation is along Z direction. Now, if it was traveling in open space, like there was no conducting walls, if there were no conducting walls, then in the direction of propagation there would be no component of electric field, neither of magnetic field. That means EZS and HZS would have been 0 if conducting plates were not there. But now conducting plate is there, then EZS will also be there, EYS will also be there, EXX can also be there, HXX can also be there, HYS can also be there, HZS can also be there. All these can exist. So based on that, we apply vector Helmholtz equations, and then we get the equation of EZS and HZS. When we were studying our rectangular waveguide, at that time also I told you the derivation is needless, it will never be used anywhere. The boundary condition will be used, so that we are going to apply. But EZS and HZS expression, how did you get? Which derivation step did you use? That is needless, that will not be used anywhere. So that derivation step we are going to ignore. So our EZX expression and HZS expression we are going to write down. In case of rectangular waveguide, what was the expression? E naught. E was a function of sine. So sine m pi by a into x, and then sine n pi by b into y e to the power minus gamma z. So this we got after applying boundary conditions. Before boundary condition, the expression was something else. There was sinusoid term as well, there was cosinusoid term as well, and there was direction of propagation as well. Similarly, before applying the boundary condition, what is your EZS here? So that is E naught Jn Kc rho cos n phi e to the power minus gamma g z. And what is your HZS? H naught Jn Kc rho cos n phi e to the power minus gamma g z. You need to keep this in your mind. Okay. Now what is what that we will discuss. Do you know what is rho? Rho is the coordinate. Like in our rectangular waveguide, we were getting cos n pi by b into y. So what was y? Y was our coordinate. So similarly, rho is our coordinate, phi is our coordinate, z is our coordinate. There the coordinates were x, y and z. Here the coordinates are rho, phi and z. So these are the coordinates. What is gamma g? You already know. That is guided propagation constant. Gamma g also you know. What is this n? As of now you consider this n as constant. Okay, as of now you consider this n as constant. Certainly it will be discussed. Certainly it will be discussed in this lecture only later on. Certainly we will discuss this n. What is this Kc? So in rectangular waveguide, what we studied? H square is equals to kx square plus ky square is equals to gamma g square plus omega square mu epsilon. So similarly here h square is equals to kc square is equals to gamma g square plus omega square mu epsilon. Are you getting this point? So there it was kx and ky. Here it is only one, that is kc. So here what I need to write is that s square is equals to kc square is equals to gamma g square plus omega square mu epsilon. So this you need to remember. In our rectangular waveguide also we were remembering it. H square is equals to kx square, then kx was replaced by m pi by a whole square, then ky was replaced by n pi by b whole square. That was equals to gamma g square plus omega square mu epsilon. So from here all the derivation started. So similar thing we are doing here. So here h square is equal to kc square is equals to gamma g square plus omega square mu epsilon. What is E naught and H naught? They are the magnitude. So now you know everything. E naught, H naught, Jn. What is Jn? Bessel function. Jn is the Bessel function. Kc, this is rho, coordinate. Cos, you already know. N is a constant. Certainly we will discuss about it. Okay. Certainly we will discuss about this n. Very important. Certainly we will discuss about it. And e to the power minus gamma gz. Is that clear to you? Same goes here. Right? Everything is crystal clear. This is your Ez dash, this is your Hz dash. What does this represent? Standing wave pattern in the direction of rho. What does this represent? Standing wave pattern in the direction of phi. And what does this represent? Traveling wave in z. Same thing is there, ditto same thing as rectangular waveguide, nothing else. Now from Ez dash and Hz dash components, we wrote down the Ex, Ey, Hx and Hy. In case of rectangular waveguide. So here what we need to write? Here what is our coordinate? Rho, phi and z. So this we are having. With the help of this we need to write down rho and phi. So same thing we are going to do here. We are going to write down E rho, E phi, H rho, H phi. So in the similar manner you need to write down. Similar, ditto similar manner. What did we use to write down? Minus gamma g upon h square. Minus gamma g upon h square. Minus gamma g upon h square. But here h square is equals to kc square, no? There h square was equals to kx square plus ky square. That was pretty big. So instead of writing kx square plus ky square, we wrote down h square. But here h square is equals to kc square. So better write down kc square only. Minus gamma g upon kc square. Minus gamma g upon kc square. Minus gamma g upon kc square and minus gamma g upon kc square. Then whatever rho you are seeing here, then del by del rho. Here what you are seeing? Phi. Del by del phi. Here what you are seeing? Del by del rho. Here what you are seeing? Del by del phi. Now if you remember how you used to write down ds for Cartesian coordinate system, that was dx ax cap plus dy ay cap plus dz az cap. So there dx, dy and dz was there. Now for cylindrical coordinate system, what you used to write down? D rho, rho d phi and dz, if you remember it. So if d phi is coming, d phi never comes alone, it comes with rho. So d phi never comes alone, d phi never comes alone, it comes with rho. Are you able to write down this thing? Say yes or no? Minus gamma upon h square, similar manner I wrote down. D phi never comes alone, it comes with rho. Is that clear? Not tough at all. Now, if this is E, so Ez dash. If this is E, Ez dash. If this is H, Hz dash. If this is H, Hz dash. In the ditto same manner, we wrote down the expressions for our rectangular waveguide as well. There this rho was not there. How rho is there now? Because d phi never comes alone, it comes with rho d phi. D phi never comes alone, it comes with rho d phi. Rest all things are d to same. Now here rho is equivalent to x, because what was our coordinate system in the previous analysis in rectangular waveguide? Our coordinate system was x, y, z. Here what are the coordinate system? Rho, phi, z. So x is equivalent to rho, y is equivalent to phi, and z is z only. So there, how did I remember the sign? Here which sign would come? There it was EXS. Now it is E rho S. So Isha is a sweet girl. Isha's x will be negative, since Isha is a sweet girl. So negative sign would come. Then what I used to write down? J omega mu upon h square. In place of h square, what I will write down? Kc. Why mu will be there? How do I remember? Because now hzs would come. Ez has already come, so now hz would come. Divided by, here there is rho, so here what will come? Phi. But phi never comes alone, it will come with rho. This is how you can write down. What we used to write down? Here we used to write down j omega mu upon h square. D by dy. Why d by dy? Because if here there was x, then here there will be y. Here if ez, here there will be hz. So similar thing we are doing here. Here if there is ez, here there will be hz. Here there is rho, so here there will be phi. But d phi never comes alone, it comes with rho. And how did I ask you to remember whether it will be mu or epsilon? What did I say? That mu always comes with h. So if there is h, so mu will be here. Because b is equals to mu h and d is equals to epsilon e. And epsilon always comes with e. So if here there is h, here there will be mu. So this is how I asked you to remember. So this is how we can write down the expression. Can you write down the expression of E phi s? So in E phi, what will be the sign? Positive sign would be there. Upon j omega mu upon kc square. If here there is phi, that means here there will be rho. And if there is ezs, then here there will be hzs. There will be no rho because d rho always comes alone. So d rho can come alone, right? What about this? H rho s. H rho s is equivalent to hxs. Himanshu is a careless guy. So his x would be positive. So plus j omega epsilon upon kc square. Here del by, here there is rho, so here there will be phi. Phi never comes alone, it comes with the rho. If there is h here, here there will be ez. And how do you remember whether it will be epsilon or mu? Because e always comes with, epsilon always comes with e. This is how you can remember. And here what will be the sign? Minus j omega upon epsilon. Minus j omega upon epsilon kc square del by del rho, in place of hzs, ezs will come, and rho can come alone. So these are the expressions you have written. In the similar, did to similar manner, we have written the expression, did to same manner. Minus gamma g upon h square d by del x ezs minus j omega mu upon h square del y hys. Sorry, hzs. This is how we used to write down. Here what we are doing? Minus gamma g upon h square. H square is equals to kc square, so I replace with kc square. Del by del rho, because here there is rho. Then ezs, the negative sign because Isha's x will be negative. So j omega mu upon h square. Del by, here there is rho, so here there will be phi. Here there is ez, so here there will be hz. And mu or epsilon, there will be confusion. So from the, for that we have remembered that mu always comes with h. Now positive sign or negative sign, this positive or negative sign, that also we have seen. Now phi never comes alone, it always comes with rho. So this is how I wrote down. So on any random day at any random hour, if I ask you h rho s, will you be able to write down? Yes. What you will say? Sir, minus gamma g upon h square. Sir, here I can see rho, so d by d rho. If there is h, hzs. Okay. Now what will come? Ezs would come. So j omega epsilon upon h square s, that is kc square. Then here, if here there is rho, so d by phi would come here. If there is rho here, here phi would come. So d phi never comes alone, it comes with rho. And then ezs. What about sign, sir? H rho is equivalent to hx. Himanshu's x will be positive. There you go. Is that clear? So will you be able to write down? Like 100% of the student will ignore this And believe me, what I feel is that if the question is coming, that will come from these equations only. In the examination, they will frame a question from this equation, because even the educators of IITs, even IIT professor knows that they will ignore these equations. Students usually ignore this equation. They will say it is very tough to remember, but no. Very easily we have written down these equation with a clear mindset and a clear trick, right? Now what we need to see? We need to see the modes. Transfer electric mode, certainly that will not be supported. Why it will not be supported? Because in transfer electric mode, if the direction of propagation is z, then EZS and HZS has to be 0. If EZS and HZS become 0, then E rho, E phi, H rho, H phi all will become 0. So no propagation will be there. So that is not possible. So let me pause a bit. Yeah, so what I was saying, transverse electric mode is not possible. It was not possible in our rectangular waveguide as well. It is not possible in our circular waveguide as well, because if EZS and HZS are 0, then all the components will be 0 and no propagation will be there. Here I did one mistake. Which mistake I did? Here I am writing EXX and HSX. No, it will be E rho S and E phi S, and these are also not correct. A rho, A phi, A rho, A phi. This Z would be there. H rho S and H phi S. These will be the component of, these will be the component, no, because here the coordinates are rho, phi and Z. There the coordinates were X, Y and Z. So for circular waveguide, the components will be rho, phi and Z. So this was the error from my side, which I made correct. Okay, so these are the E rho, E phi, H rho, HS, H phi components, and these are EZ, HZ components. So this you need to keep in mind, and this you don't need to mug up, but you need to have a trick to write down these expressions, right? So EZS E naught J n Kc into rho cos and phi e to the power minus gamma gz, and HZS is H naught J n Kc into rho Kc into rho cos and phi e to the power minus gamma gz. Now it feels like that, sir, both of the expressions are same, only the magnitude is different. But wait a minute, when we study the modes, TE mode and TM mode, then these Kc value will be different. When we studied rectangular waveguide, at that time as well, EZS and HZ components were looking same. But when we applied the boundary condition, then in EZ, sine component were left, and in HZ, cos component were left. So similar thing will happen here as well. When we apply the boundary condition, then these Kc's value will change. Okay. So now we need to study about the modes. So TEM mode doesn't support. What about TM mode? Transverse magnetic. So magnetic field is transverse. That means HZS is 0, but EZS is non-zero. Right? This you already know. TM mode. There at that time, our subscript was Mn. Here the subscript will be Np. Why Np? I will tell you. Okay. Do not worry about it. In the rectangular waveguide, the subscript were Mn, but here the subscript will be Np. What is our EZS expression? E naught Jn Kc into rho cos and phi e to the power minus gamma gz. This we have already seen. So this represent our standing wave. This also represent our standing wave, and this represent our traveling wave. Now boundary condition. So you take this portion. Which portion I am taking? This portion I am taking. This circular portion I am taking. So in this circular portion, what is happening is that this is your rho. Rho is increasing from 0 to a. This is your rho equals to 0, and this is your rho equals to a. Now at rho equals to a, there are two components. One is this tangential component. One is this tangential component, and other one is this tangential component. And what is this? This is a conducting surface, right? This surface is conducting, right? This all surface are conducting. So this boundary is also a conducting surface. This boundary is also conducting surface. So at rho equals to a means you are at the boundary. So at the boundary, the tangential component of electric field will be 0. What does our boundary condition says? Our boundary condition says that at the conducting surface, the tangential component of electric field will be 0, because I told you at the conducting surface the electric field will always be perpendicular. So these tangential component will be 0. So here what are the tangential component? So this is my rho. What will be this component? E phi. And what will be this component? Ez. Say yes or no. This is a circle. Let's assume this circle. This is a circle. So if I take a slope on this point, on this point, so that will be in the direction of phi, no? On the perimeter you take any slope, that will always be in the direction of phi. This we have studied in our cylindrical coordinate system. And this will be the direction of z. I mean to say that this is my circle. This is my circle. Here if I take any slope, that will be in the direction of phi, and this will be in the direction of z. So this will be in the direction of z. So at the boundary, you are having two tangential components, that is E phi and Ez, and both will be 0. So at rho equals to A, Ez will be equals to E phi s will be equals to 0. But I don't need to care about E phi s because I am not having the value of E phi s. So what I need to care about? I need to care about Ez s, right? So now I need to care about Ez s. So Ez s at rho equals to A. So rho equals to A I will put here. So what is the value of Ez s I am getting? So let's write down the value here only. Ez s at rho equals to A. So E naught Jn Kc rho equals to A. What is A? A is the radius of your circular waveguide, or you can say radius of the cross section of circular waveguide. Are you getting this point? Because the cross section is circular and that radius is there. So radius, this is your A. This length is your A. Cos n phi e to the power minus gamma g z. This is your Ez s, that is equivalent to 0 at rho equals to A. So E naught Jn Kc into A cos n phi e to the power minus gamma g z is equals to 0. So here you did not put the value of phi, do not put the value of z, you put the value of rho. So only you can comment about this guy. So E naught cannot be 0, this cannot be 0, this cannot be 0. So who has to be 0? Jn Kc A has to be 0. And if Jn x was 0, then x was equivalent to x and p. So if Jn Kc A is 0, so Kc A is equals to x and p. So what is the value of Kc you are getting? X and p by A. In the previous cases, in rectangular waveguide, we were getting the value of Kx as m pi by A and Ky as n pi by B. But what is happening here? In this case, Kc value only we need to find, that is coming out to be x and p by A. So Kc value is coming out to be x and p by A. So now what will be the expression? Ez was E naught Jn Kc rho cos n phi e to the power minus gamma gz. So now your Ez would become E naught Jn Kc into rho. What is the value of Kc? X n p by E. Kc into rho cos n phi e to the power minus gamma g z. And which mode we are studying? We are studying about transverse magnetic mode. So in transverse magnetic mode, certainly our Hz will be equals to 0. So you write down the expression of E rho, E phi, H rho and H phi. So what will happen? Hz is 0. Hz is 0. So this term will go to 0, this term will go to 0, this term will go to 0, this term will go to 0. So what will be the equation? So when you write down the equation, what you will understand, sir, minus gamma g upon h square del by del rho Ez. Next term will be 0, sir. So this expression you will be getting. Now you just need to differentiate with respect to rho. So what you get? Minus gamma g upon Kc square E naught as it is. With respect to rho we need to differentiate. That means this differentiation we need to do. Jn x was differentiated with respect to x. So what did you get? Jn dash x. When this was differentiated with respect to x. Now this is being differentiated with respect to rho. So what you will get? Now the scene is Jn x n p by A rho. This is being differentiated with respect to rho. So what you are going to get? These are constant. So if fx is differentiated with respect to x, you get f dash x. If f ax is differentiated with respect to x, what do you get? F dash ax, then differentiation of this, so a comes outward. Same thing will happen here. So what I will get is that this is being differentiated with respect to rho. So what will happen? Jn dash x np by a into rho, but what will come outward? X np by a. Are you getting this point? Cos n phi e to the power minus gamma g z. So this is acting as a constant value only, which we don't care about. So here we can see that it is a function of Jn dash and cos n phi. Simply differentiation we are doing, just we are writing down the expression. It is simple mathematics, nothing else. And you do not need to remember anything. Just see it and forget it. You just need to know that we have done this kind of analysis. If some question is coming from this particular analysis, then believe me, only you guys will be able to solve. Because no one teaches to remember these equations. No one actually remember these equations. But in the simplest manner, I have told you how to remember these equations. Now in the examination, if this expression is coming, then just by looking at the expression, you will get to know that it is E rho S expression. And you will be able to tell that it is TM mode. So these kind of questions can come in your examination. They can ask you to recognize the mode, that which mode it is. These kind of questions we saw in rectangular waveguide. So now these kind of questions can come in circular waveguide as well. Right? So those questions also we are going to see. But now let's see E phi. So what will be E phi? So minus gamma g upon rho kc square. Then you need to differentiate with respect to phi. So this term will come as it is. Differentiation is done with respect to phi. So cos phi is differentiated with respect to phi. So what it will give you? Minus n sin n phi. Right? Because the differentiation of cos is minus sign. So minus sign will be gone, and from cos n will also come outward. N will also come outward, and then E naught will remain there as it is. Then this Jn x np by a into rho cos n phi, no sorry, differentiation of cos is sin n phi e to the power minus gamma g z. What about h rho s? So j omega epsilon upon rho kc square. Now you need to differentiate with respect to phi. So again, if I differentiate with respect to phi, then n will come outward. So n will come outward, and minus sign will also come outward. Then Jn kc is x np by a into rho, and differentiation of cos is sin n phi e to the power minus gamma g z. What about this differentiation with respect to rho? So here kc square minus sign is also there. Now you need to differentiate with respect to rho. We need to differentiate. So what will come outward? X np by a into x np by a, x np by e, then E naught, then with respect to rho we are differentiating. So Jn dash x np by a into rho cos n phi e to the power minus gamma g z. So what I mean to say is that in rectangular waveguide we studied that our electric field was a function of sin x sin y, Ez was a function of sin x sin y, and Ex was a function of cos x sin y, and this was working for both TE and TM mode, and Ex was equivalent to Hy, and from there I could write down the Ey expression as well, which was sin x cos y, and this was equivalent to Hx. So this was very easy to remember it, because it was working for both TE and TM. Now when we derived the equations for TE mode, you will realize that the expressions are different. What I mean to say is that you cannot say that E rho will always be a function of Zn dash and cos. No, it will be changing in case of TM mode. So here it's not worth to remember these expressions, that E rho is a function of Jn dash cos n. No, it's not worth to remember the expression. So what we will do in the examination? We will remember only this one. And if we remember this one, then directly we can write down E rho as well. What I mean to say is that in the examination, somehow I got to know that it is my Ez mode, and I require to write down E rho expression. I just need to know that it will be a function of what. So that I need to know. So what I will think, okay, I go to know that it is my TM mode. If it is a TM mode, that means EZS is existing. EZS is existing. So EZS is a function of E naught, Jn, Kc something and cos and phi something. So this I need to remember. This I need to remember. Now I need to write down E rho. So what I will write down? Minus gamma g upon s square. Then del by del rho EZS. So Ez will be differentiated with respect to rho. So this is your Jn rho and this is your cos and phi. Jn rho and cos and phi. So what will be differentiated? Jn dash will be differentiated. So your E rho s will be a function of Jn dash and cos and phi. It will be a function of Jn dash and cos and phi. So in the examination only you can do the differentiation. No? In case of circular waveguide, it is not worth to remember E rho, E phi are function of what. In case of rectangular waveguide, it was very easy to remember. We remember that Ez was a function of sin x sin y, Hz was a function of cos x cos y, and Ex was a function of cos x sin y. So from there we could write down everything, and it was same for both TE and TM mode. But as of now we have derived only for TM mode. So in circular waveguide you will realize that in TE mode the expression are different. Here E rho is a function of Jn dash and cos and phi, but in case of your TE mode, this is your TM mode. In TM mode, E rho is a function of Jn dash cos. But in case of TE mode, E rho will be a function of Jn and sin. So those expressions are different. So that's why it is not recommended to remember anything, any result. What I am saying, you do not need to remember any result. You just need to know the process. But in case of rectangular waveguide, if you remember the result, then problem will become much easier. But in case of rectangular waveguide as well, you can follow this differentiation method, which I have told here. So there also you can follow this differentiation method. But usually we remember in case of rectangular waveguide, right? So here I am not asking you to remember. Why is that so? Because expression will be different for TE and TM modes. Again, I need to take a break. Okay. Then I will explain you what is the meaning of this N and P. So that will be our next topic. What is the meaning of this N and P? But I need to take a break now. Yeah, so let's start our analysis again. Now we need to see the meaning of N and P. And one more thing before starting this analysis, when I was saying that TEM mode doesn't exist, at that time I said the full form as transverse electric, but that is wrong. The full form of TEM is transverse electromagnetic. That was just a slip of tongue. I hope you must have understood. The full form of TEM is transverse electromagnetic mode. So TEM mode doesn't exist. Transverse electromagnetic mode doesn't exist because for transverse electromagnetic mode, EZS and HZS will be 0, and if both of them are 0, then E rho, E phi, H rho and H phi all will be 0. So no propagation will be there. So that was a slip of tongue. When I was rewatching the video, at that time I noticed that there was a slip of tongue. So TEM means transverse electromagnetic mode. Certainly TE mode will exist. Transverse electric mode will certainly exist, right? Now let's understand the value, the meaning of N and P. So in our rectangular waveguide, M was associated with X and N was associated with Y, right? So M was the number of half cycle along X and N was the number of half cycle along Y. In case of rectangular waveguide, here N is associated with phi and P is associated with rho. So N is associated with phi and P is associated with rho. So this is associated with phi and this is associated with the radius. P is associated with the radius. Now let's understand about P. So if I write down EZ expression, what do I get? E naught Jn x n p by a rho cos n phi a to the power minus gamma g z. Let's focus on this part only. Because we need to understand about P. So I am focusing only on this part. So at rho equals to a, what I am doing? At rho equals to a, what this part will become? This part will become Jn x n p, right? Now let's get back to at rho equals to a, this part will become Jn x n p. Let's get back to our Bessel function now. This was the graph of our Bessel functions. So now what we are doing is that, what I am saying is that at rho equals to a, what do you mean by rho equals to a? Rho equals to a means you have covered the complete circular waveguide. That means you have come at the boundary of the waveguide. because rho equals to a is at boundary, and at rho equals to a, your Jn function that was x np by a into rho. So this function would become Jn x np. And what is the value of Jn x np? That is 0 only. Value of Jn x np is 0 only. Now let's just say randomly I am taking n value as 0. So what I will write? J0 x 0 p is equals to 0. Now let's just say I pick the value of p equals to 1. What I am saying? Now my p is 1. This is what I am saying. What does that mean? P is 1. Where will be your p equals to 1? P is 1 means what is the first time for n equals to 0 you are getting 0. What value? P equals to 1 means for the first time you are getting your 0. So where you are getting your 0 for the first time? For n equals to 0. So n equals to 0 means you need to look at this curve only. I am looking at this curve. So for the first time I am getting 0 here. Right? So now if p equals to 1, if p is equals to 1, that means in the complete boundary, in the complete circular waveguide, you are getting 1 minima and 1 maxima. If p is equals to 1. Now let's just say if I say p equals to 2. If p is equals to 2, that means any 0 and any random value of n I am putting. Any random value of n I am putting, I have put n equals to 0. Now I am changing the p value. P equals to 1, p equals to 2. If p is equals to 2, that means I am talking about what I need to see, this curve. That means I am talking about this point. If p is equals to 2, that means I am talking about this point. So in your complete circular waveguide, you are getting 1 0, 2 0 and 1 maxima and 2 maxima. This is maxima only. Like you can take the magnitude. If you are talking about Jn x np by a into r, this will make a standing wave pattern. If this is making a standing wave pattern, then you need to take the magnitude of this one. So actually this is maxima only. So this is not minima, this is maxima. You need to take the amplitude. So if p is equals to 2, then in your complete boundary, because rho equals to a I have put, so in your complete circular waveguide, along the radius, you are getting 2 maximas and 2 minima. If my p is equals to 3, that means where I am, this is p equals to 1, this is p equals to 2, this is p equals to 3. If my p is equals to 3, that means I am at this point. And now in this point, 1, 2, 3 zeros has come, and 1 maxima, 2 maxima and 3 maxima has come. So when p equals to 1 was there, that means 1 0 was there and 1 maxima was there. When p equals to 2 was there, at that time 2 maxima were there and 2 0 were there. When p equals to 3 was there, that means there was 3 maxima and 3 0. Are you getting this point? Right? So what did you understand from this analysis? That what is your p? P is the number of zeros or maxima along the radius of the waveguide. So when I took the complete radius, when I took rho equals to a, and then I changed the value of p, I put the value of p as 1, 2 and 3. I got to know that when I put p equals to 1, my number of maxima or number of 0 is 1. When p is equals to 2, number of maxima and number of 0 is 2. When p equals to 3, number of maxima or number of 0 is 3. So what does it represent? Along the radius of the waveguide, number of maxima or number of zeros. This is what p represents. Did you understand this point? So p is not that important, but understanding it was important for you, that what does p represent. So in the language, sometimes they can ask that along the radius of the waveguide, you are getting 2 maximas. That means your value of p is 2. So you need to understand what is the meaning of p, because in the language it can be written. Are you getting this point? Now what is your n? So now we need to study about n. So when we need to study about n, where I will look? Cos n phi. So can you draw the graph of cos n phi? Yes. What I will do, first I will draw the graph of cos phi, then I will divide the x axis, or you can say I will divide the phi axis by n. So this will be my graph of cos phi. So cos phi will go something like this. And if I need to make the graph of cos n phi, then I will divide the phi axis by n. This we have already seen, right? This we have already seen. Now what is the range of phi? Range of phi is 0 to 2 pi. On your circular waveguide, the range of phi is, it goes from 0 to 2 pi, right? So you have 0 to 2 pi window. Now if you put n equals to, let's just say if I put n equals to 1, if I put n equals to 1, then what this will become? Pi. What this will become? 2 pi. What this will become? 3 pi. What this will become? 4 pi. But how much range I am having? I am having the range till 2 pi only. So only this much window I am having. Only this much window I am having. That means till this point only I am having the window. So if n is equals to 1, then how many half cycles you are getting? If n is equals to 1, this is one half cycle, then this is another half cycle. So number of half cycle you are getting is 2. If n is equals to 1, the number of half cycle you are getting is 2. 2 half cycles you are getting in the 2 pi radian distance, or you can say 2 half cycle I am getting in the field variation of 2 pi. So what you are getting, if n is equals to 1, you are getting 2 half cycles, or you can say I am getting 1 full cycle in the field radiation of 2 pi. If n is equals to 1, in the field radiation of 2 pi, you are getting 1 full cycle. Say yes or no. Do you agree to this point? Here I am not talking about half cycle, I am talking about full cycle now. If n is equals to 1, then in the field variation of 2 pi, in the field variation of 2 pi, you are getting 1 full cycle. Or what you can say, if my n is equals to 1, then in the field radiation of pi, I am getting 1 half cycle. If my n is equals to 1, then this will be pi, this will be 2 pi, this will be 3 pi, this will be 4 pi. So if I take the range from 0 to pi, then I am getting 1 half cycle, and if I take the range from 0 to 2 pi, I am getting 1 full cycle. Let's take more example, it will be more clear to you. I know this is slight confusing for you, but let's take more example. Let's take the example of n equals to 2. So if I put n equals to 2, what this will become? Pi by 2. What this will become? Pi. Because 2 pi by 2 will be pi only. What this will become? This will become 3 pi by 2. And what this will become? 2 pi. So if n is equals to 2, then in the field radiation of 2 pi, what will be the field radiation of 2 pi? This will be the field radiation of 2 pi. This is the complete field radiation of 2 pi. So if n is equals to 2, then in the field radiation of 2 pi, you are getting 1 full cycle, then another full cycle. So you are getting 2 full cycles. When n is equals to 2, then in the field radiation of 2 pi, you are getting 2 full cycles. Or you can say, or what you can say, when n is equals to 2, then in the field radiation of pi, I am getting 2 half cycles. When n is equals to 2, then in the field radiation of pi, I am getting 1 and 2 half cycles. Is that clear to you or not? Let's take more example. Okay, but I hope I have given enough examples to you, but let's take more. Let me make this curve better now. Now let's take n equals to 3, but here it will be 5 pi by 3 only, no? So let's make it more. So here it will be 6 pi by n, 6 pi by n. This will be 6 pi by n. If I put n equals to 3, then what will happen? This will become pi by 3. I don't know what this will become. This will become pi. And what this will become, I don't know, but this will become 2 pi. So in the field radiation of 2 pi, if n is equals to 3, then in the field radiation of 2 pi, you are getting 1 half cycle, 2 half cycle, sorry, not half cycle, full cycle. 1 full cycle, 2 full cycle, and 3 full cycle. So if n is equals to 3, then in the field radiation of 2 pi, you are getting 3 full cycles. What about half cycles now? So when n is equals to 3, then in the field radiation of pi, when n is equals to 3, then in the field radiation of pi, you are getting 1, 2, and 3 half cycles. Are you able to understand this point? So what does n represent? What does your n represent? So n represent number of full cycles of field radiation in 2 pi radian of phi, and or you can say number of half cycle of field variation in pi radian. Are you getting this point? So in 2 pi you are getting, when n was equals to 3, so in 2 pi you are getting 3 full cycles, and in pi you are getting 3 half cycles. So anything can be written in the language, you should be able to understand. So if it is written, then in the field variation of pi you are getting 3 half cycles. What does that mean? The value of n is equals to 3. Or in the field radiation of 2 pi, you are getting 3 full cycles. Then what is the value of n? N is equals to 3. So half cycle, full cycle, is this concept clear? The range is clear, pi, 2 pi, is that clear? So value of n is 3. And what is the value of p? P tells along the radius how many maxima and 0 you can say, or minima also you can say. So along the radius how many maxima and minima you are getting. So this is what is known by, this is what is told by value of p. So is that clear what n and p represent? Not that important, but who knows, in the language they can mention sometimes that rather than calling n and p, they will write down these languages, that along the radius, along the full radius of the circular waveguide, the number of maxima you are getting is 2. That means the value of p is 2, right? And if they say that along the field radiation of 2 pi, in the field radiation of 2 pi, along the field radiation of 2 pi in your circular waveguide, you are getting 3 full cycles of field variation. 3 full cycles of field variation. If you are getting 3 full cycles of field variation, that means value of n is 3. And they can say that in the variation of pi, from 0 to pi, you are getting 3 half cycles. That means value of n is 3. Is that clear to you? Meaning of n and p is clear to you? How did we determine it? That also clear, right? Okay then. So for this one, we took the example of, for determining the value of p, we will always look at rho, and for determining the value of n, we will always look at phi, right? So I can remove this off. Okay. So that is also clear. Now what will be the non-propagating modes? What do you think? What do I know is that p value can never be 0. That's it. Those will be the non-propagating mode. That means Tm and 0 will be the non-propagating mode. Rest all are propagating. That means Tm 0p is propagating, Tm and p is also propagating, where p is not equals to 0. So the only condition is p cannot be 0. That's it. So which of the modes are propagating mode? This is also possible, this is also possible, this is also possible, this is not possible. Value of p cannot be 0 because there is no meaning that pth 0th 0. I told you about this thing. P can never be 0. Why p can never be 0? Because when you are studying Bessel's function, what did I tell you? P is the number of time that zeros are occurring. Number of time the roots are being 0, or you can say the number of times zeros are occurring. So at least once 0 will occur, no? So p can never be 0. So the thing is, p can never be 0. So non-propagating mode will be Tm and 0. Same goes for TE mode as well. In TE mode as well, the non-propagating mode will be TE and 0, because p can never be 0. N can be 0. You can put n equals to 0. You can put n equals to 0 in these equations. You will understand that if I put n equals to 0, then h phi s is existing. If I put n equals to 0, then this is not existing, but h phi s is existing. If I put n equals to 0, this is not existing, but e rho s is existing. And if I put n equals to 0, then ez s is also existing. So n equals to 0 is acceptable, but p equals to 0, if you put p equals to 0, then this value doesn't make any sense. If you put p equals to 0, this value doesn't make any sense. So p equals to 0 you cannot put. So non-propagating modes are Tm and 0. So let's revise whatever that we have studied in our Tm mode. So first we studied that Tm mode doesn't support, then Tm mode we started studying transfer magnetic, that means magnetic field is transverse. So Hz is 0, Ez is non-zero. Ez expression we wrote down, E naught J and Kc E naught J and Kc rho cos and phi e to the power minus gamma Gz. Then our target was to find the Kc value. For that we applied the boundary condition. At boundary condition, Ez component will be 0. From there we got to know that Kca is equals to x and p. So Kc value we got x and p by a. Then we put it, and then E rho, E phi, E rho, E phi, H rho, H phi component we can find out, because we know the equation of E rho, E phi, H rho and H phi. And how do we remember that expression? By our trick. So here we know that Hz will be 0, so that component I don't need to write, only Ez component I am gonna write. Then I go to know that here E rho is a function of J and S cos and phi, but this is not worth to remember. Eventually in the examination I will only remember Ez, and from Ez I will derive all these expressions if it is required. Then we study the meaning of n and p. So what does p represent? So p is the number of zeros or number of maxima along the radius. Along the radius, how many number of zeros or number of maxima you get in circular waveguide. And what is your n? N is associated with pi. So along the 2 pi radian, or along the from 0 to 2 pi, along 2 pi radian, how many number of full cycles you are getting? Because in 2 pi, if you are taking the number of full cycles you need to take, and if you are taking pi, that means if you are taking from 0 to pi, if you are taking the value of pi from 0 to pi, so in the field variation of 0 to pi, how many number of half cycles you are getting? That is denoted by n. So n and p, this is clear. So within 2 to 3 minutes, you will be able to do the revision of this circular waveguide, because you have studied rectangular waveguide very clearly. So this will be very easy. Just the point was, this was interesting point, that what do you mean by n and p? These were the interesting words, that how you write down the equations. When we see the waveguide parameter, those will be very, very easy, because formula will be exactly same. When we see the waveguide parameters like beta g, lambda c, fc, those value we will find out, those will be very easy. But the equations part is a bit typical. If you remember in rectangular waveguide as well, the equation part is a bit typical, but we have seen it in a very good manner. Very patiently we are solving these part. Also we have understood the deep meaning of our Bessel's function as well. Not deep meaning I would say, but whatever that is required for you at your level for your examination, every single thing we have seen about Bessel function as well. Also the differentiation of Bessel function as well. Is that clear to you? Everything is crystal clear. Now let's move to our TE mode. So in TE mode, electric field is transverse. So how we will represent? TE NP. And now you must have understood why we represent by NP. Because 2 are the defining parameter of X and P. So these are the defining parameter NP. That's why we represent the subscript is NP only. That's why the subscript is NP. So transverse electric field is transverse. That means electric field is 0 and HZS is non-zero. So what is the expression of HZS? H naught Jn Kc rho cos n phi e to the power minus gamma gz. Now if I need to apply the boundary condition, that means I need to come at rho equals to A. If I need to apply the boundary condition, what does that mean? That means I need to come at rho equals to A. So at rho equals to A, I know that tangential component of electric field will be 0. That EZS and E phi s will be 0. At rho equals to A, EZS and E phi s will be 0. But I don't know anything about the magnetic field. But I am having the expression of magnetic field. At rho equals to A, I know that my EZS and E phi s will be 0. That means tangential component of electric field will be 0. But I don't know anything about our HZS. So what I need to do? I need to use these equations. Right? Why I need to use these equations? Because I need to find the relation of HZS. I need the relation of HZS, not about EZS and E phi s, because I have the expression of EZS with me, no? So I need to do something, I need to apply the boundary condition, but I need to get something in the expression of HZS, not in the expression of EZS, because EZS is already 0. Here E phi s will also be 0. So can you write down E rho, E phi, these expressions? Yeah. How will I write down? E rho is minus gamma g upon h square. So that expression I am not going to write down, because here del EZS would come. Then after that what comes? Minus j omega mu upon kc square d by d phi hzs, and here d phi never comes alone, so rho will come. So rho d phi. This is one of the expression of E rho. But I don't need E rho, I need E phi. Why do I need E phi? Because I know that at boundary my E phi s is 0. So can I write down the expression of E phi? That is minus gamma g upon h square del by whatever that is there, because here EZS would come, so that I don't need to care about. Then what will come? Plus j omega mu upon h square del by del rho hzs. So if E phi s is equals to 0, that means this expression has to be 0. So here I have written E phi is j omega mu upon kc square del hzs by del rho. So if E phi s is 0, that means differentiation of this hzs function with respect to rho should be equals to 0. So can you do the differentiation? Can you find out the value of del hzs by del rho? That would be h naught. Now I need to differentiate this, because I am doing the differentiation with respect to rho. So if I differentiate this one, what do I get? Kc comes outward, jn dash kc rho cos n phi e to the power minus gamma g z. That should be equals to 0. Now what do I need to put? I need to put rho equals to A, because this is 0 at rho equals to A. At the boundary it is 0, no? So I need to put rho equals to A here. So what I'm going to put? Rho equals to A. So value of rho I have put. I cannot comment on this, I cannot comment on this, I cannot comment on this. Only value I can comment on is this. So what do I get from here? That Jn dash KCA, Jn dash KCA is equals to 0. Okay. So all these steps are gone because we have done all these steps already. So directly this step will be required, that Jn dash KCA will be 0. Why Jn dash KCA is 0? I hope you must have understood, right? Why it is 0? Because this I am putting equals to 0. So this has to be equals to 0 only. So Jn dash KCA is equals to 0. Now what did I tell you? If Jn dash x is equals to 0, then x is equals to x dash np. This we have already studied. So here KCA is equals to x dash np. So Kc value is coming out to be x dash np by A. So what did I tell you? The expression of Ez dash and Hz dash looks similar. Here when we were studying this, when we were on this slide, I told you that these expression look similar, but Kc value here will be different. This will make the difference. So in transverse magnetic mode, when Ez was existing, what was the value of Kc? X np by A. Now in Hz, in transverse electric mode, when Hz is existing, at that time what is the value of Kc? X dash np by A. So Hz dash can be written as H naught Jn x dash np by A into rho cos n phi e to the power minus gamma g z. Yeah, that's it. So this was the thing. This is your Hz dash. Now from these Hz dash, what all you need to determine? E rho s, E phi s, H rho s and H phi s. By using which equations? Those 4 equations that we write down. Minus gamma g upon Kc square, del by del rho, Ez s. Using those equations, we need to determine these values. So can you do it on your own? Pause the video and write down the expression of all these things on your own without even looking back. First you need to write down the equation. Let's just say E rho s I am writing. So minus gamma g upon h square, del by del by del rho Ez s. But that step will be gone because Ez s is 0. Then what will be the next step? Next step will be minus j omega mu upon Kc square d by d rho Hz s, and then rho will be there, and then do the differentiation. Do the differentiation on your own as well, and then write down the final result. So only mathematics is there now, right? You know every single thing. Only mathematics is involved. So these will be the expressions. This is the expression of Hz s, right? Because here Kc value we were getting x dash np by A. Now what will be your E rho s? E rho s will be minus j omega mu upon rho Kc square, because phi never comes alone, and then do the differentiation. Here what you are seeing, E rho is a function of Jn sin phi. Previously E rho was the function of Jn dash cos phi. So easy what to remember. In case of rectangular waveguide, Ex s was always a function of cos x sin y, no matter whether it is your no matter whether it is TE mode or TM mode. No matter whether it is TE mode or TM mode, it was always a function of cos x sin y. So at that time I told you that you can remember only Exx. Then Ex is brother of Hy, and then Ex will be opposite to Ey, and Ey is a brother of Hx. So all the expression was very easy to remember there. But here, rather than remembering the expression, what I'm going to do is that I'm going to do the differentiation in the examination. Or if you want to remember anyhow, making any trick, then you can remember. But I recommend not to remember, but better to do this differentiation in the examination, because that will not be difficult. Because in the examination, if I need to determine the field, if I need to determine the mode, let's just say I need to determine the which mode is it. If I need to determine that thing, then what I'm going to do in the examination? In the examination, I'm gonna only do this thing. In the examination, I'm gonna only do this thing. I'm not gonna care about these stuffs, that what will be the magnitude. Because what I need to see there I need to see Jn and cos. Either Jn dash would be there, cos phi would be there, what will be there, that I need to see. So these are our E rho, E phi, those expressions. Just notice one thing here, that our HZS is a function of Jn rho I am writing and cos phi I am writing. Okay, HZS is a function of Jn rho cos phi. Here there is any factor that I don't care. Jn cos, same goes for EZS as well. Same goes for here EZS as well, that it is a function of Jn rho cos phi. Now no other function, neither E rho, neither E phi, neither H rho, neither H phi is a function of Jn cos. Jn rho cos and phi you will never find anywhere. In E rho will you find Jn and cos? No. Here you are finding Jn dash. Here are you finding Jn and cos? No. Here you are finding Jn and sine. Why is that so? Because one of the factor will be differentiated. No, that's for sure. What I am saying is that one of the factor will be differentiated. No, either rho will be differentiated or phi will be differentiated. So Jn rho and cos phi you are never gonna get in E rho, E phi, H rho and H phi, whether it is your TE mode or TM mode. In TM mode also it is the same, and in TE mode it is also the same. In TE mode as well you are never going to get Jn cos. Here you are getting Jn, but here you are getting sine here. Here you are getting Jn dash, but here you are getting cos. Here you are getting Jn dash, here you are getting cos. Here you are getting Jn and sine. Did you understand this point? So only I am asking you to remember this expression and certainly this expression as well. Certainly this expression as well. Okay, so if you remember only these two expressions, then other expressions you will be able to derive. We will certainly solve the problems as well. And believe me, if these kind of problems will come in the examination, I should not say, but even teachers will skip it. Okay, because I have seen like in analog some problems came and some educators were saying that we skipped those problems because these were very easy. So yeah, so even teachers will skip these kind of problems if that is coming in the examination. These are very good. Okay, and you have build a good amount of problem solving skills, you have good amount of patience, you have good amount of knowledge as well, that how to determine E rho, E phi, H rho, H phi expressions. So now let's see some questions, or before that we will see the non-propagating mode and propagating mode. So what will be the non-propagating mode? That you already know, that would be TE and 0, because P value can never be 0. And what will be the propagating mode? All those modes will be propagating, that is TE 0P, TE 0P and TE NP, where P is not equals to 0. So all other mode will be propagating. Now they are asking what are the possible modes for circular waveguide. So wherever you see 0, this will not be possible. Wherever you see 0, this will not be possible. Rest all will be possible. Rest all are possible. So wherever P is 0, that is not possible. Rest all are possible. That's it. Now what they are asking, which of the modes are possible in both circular and rectangular waveguide? It should be possible in both circular and rectangular waveguide. So non-propagating mode I am writing, non-propagating modes. Okay. So at one end rectangular waveguide, at one end circular waveguide. So in circular waveguide the thing is only P cannot be 0, that's it. But in rectangular waveguide T 0 0 is not existing, or in case of TM no 0 can be there, like 0n cannot be there and M0 cannot be there. So these are the non-propagating mode in rectangular waveguide and circular waveguide. Say yes or no. So what they are asking, possible mode in both of the waveguides. So is this possible in, let's eradicate those modes which are not possible in circular waveguide first. So is this possible in circular waveguide? No. Is this possible in circular waveguide? No. Is this possible in circular waveguide? No. Now let's eradicate those modes which are not possible in rectangular waveguide. So is this possible in rectangular waveguide? Yes, it is possible. Is this possible in rectangular waveguide? No, this is not possible in rectangular waveguide, because in rectangular waveguide TM can never be 0. TM can never be 0. So M value can also never be 0. So this is also not possible. Is this possible? Yes, it is possible in both. This is also possible in both. This is also possible in both. And this is also possible in both. Because for TE, 0, 1 can be there. And for circular waveguide as well, 0, 1 can be there. N value can be 0. So if N value is 0, then you are fine with that. So this is the answer. So this is also a good question, that which modes are propagating for both of the waveguide. So these kind of questions can also come. So we will see all the possibility of questions that can be asked in your examination. So possible mode, this is the first one, and this is the second one, that you need to determine the mode, whether it is TE or TM. So look at the first expression. So looking at the first expression, what did you get to know? That this is certainly your ERO. What is this? This is certainly your ERO. How did you determine it is ERO? Because of this arrow cap. So this is certainly your ERO. So now this ERO can be coming from TE mode as well and TM mode as well. It could be coming from TE or TM, any one. Now I need to determine whether it is from TE or TM. So in case of TE mode, what will happen? HZ is non-zero. HZ is non-zero, right? And if I need to write down ERO there, so what I will write down? What will be my ERO? ERO will be minus gamma G upon H square, that component will be gone, and then J omega mu minus J omega mu upon Kc square D by D rho HZ, right? And certainly rho will also come, but I don't need to care about this expression. I just need to know that ERO will be del by del phi HZ, right? Now differentiation is done with respect to phi. Differentiation is done with respect to phi. So what I will get? Some constant value. Then differentiation is done with respect to phi, so Jn will remain there as it is. And since differentiation is done with respect to phi, then it will be sin phi. So here you should be getting sin and Jn, but what we are getting? Jn dash and cos. So certainly it is not your transverse electric. So this is not possible. What about transverse magnetic? So let's check for transverse magnetic as well, because the option could be mentioned that this field is not even possible, right? There can be three answers: TE, TM, or field is itself not possible. So this can also be one of the answer. So let's check for TM now. So TM means EZ will be non-zero, because in magnetic field is transverse, so EZ is non-zero. So if I need to write down the ERO expression, what that would be? Minus gamma G upon H square del by del rho EZ. So differentiation is done with respect to rho. That means what I will get? Some constant value, then Jn dash, and phi will remain there as it is. So cos and phi will remain there as it is. So Jn dash, cos and phi. So that means this is the answer. So what is the answer? This is your TM mode. So will you be able to determine the mode? Now they can give you the value of N and P as well. Like anyhow they can mention the value of N and P as well, then it could be TM some NP mode. So that NP value here it is not given, N is written as N only, and here they did not even mention XNP value. So we will see these kind of examples where we need to determine the NP value as well. But as of now we are just determining whether it is TE or TM. So it is your TM. So this is how you are gonna determine in the examination. So no mugging up, only what do I remember? I only remember that my HZS, it is a function of Jn rho and cos and phi. And same goes for my EZ. It is also a function of Jn rho, cos and phi. Is it tough to remember? Certainly it is not tough to remember. So if you just remember these two things, then all the problems will be solved. Let's start the next one. H field expression is given. Here they did not write any AZ, A rho, A phi, anything. So what do you think? What is this? Look, if they don't write anything here, then certainly it will be HZ only or EZ. But since it is a magnetic field expression, then it has to be HZ. But how you can tell it is HZ only? Because Jn and cos, and it is only possible in case of HZ. So it has to be HZ. In rest of the cases, you can get Jn dash sin phi, or you can get either you can get Jn dash cos phi, or you can get Jn sin phi. But Jn cos phi, if you are getting, it has to be HZ. So what is this? This is your HZ expression. That means if HZS is existing, then which kind of mode it is? Transverse electric mode. So this is your transverse electric mode, because electric, if HZS is there, that means EZS would have been 0. So electric field is transverse. So TE NP mode. Let's see the next one. In the next one, what is given? H5 is given. You can directly see that what is mentioned? H5 is mentioned because here you can see it is E5. So H5 is mentioned. So again, there are two possible answers. Either it could be TE or TM. TE or TM, right? If I say it is transverse electric, then Hz dash will be non-zero. That means if I need to write down the expression of H5, what that would be? H5 I am writing. So minus gamma g upon h square del by del by del phi. Phi never comes alone, it comes with rho Hz. That's it. If Hz is non-zero, then this is the expression. Then next will be Ez. So Ez is 0, so that expression I am not gonna write down. So what we are getting? Some constant we will get, and Hz is a function of Jn rho and cos and phi, and differentiation is done with respect to phi. So Jn will come as it is. Jn will come as it is, and differentiation is done with respect to phi. So this will be sin and phi. So are you getting this thing? Jn as it is and sin and phi. Yes, this is your transverse electric mode only. So this is your transverse electric mode NP. So this is the answer. Or you can check for TM mode as well. So if TM mode is there, that means Ez is non-zero. If Ez is non-zero, you need to find H5. So what will happen? Minus gamma g upon h square, first term will be of Hz, that will be gone. Then j omega epsilon minus j omega epsilon upon h square del by, in the first term there will be del by del phi. So here it will be del by del rho Ez. Okay. So Ez is differentiated with respect to rho. Ez is differentiated with respect to rho. With respect to rho means Jn dash rho cos n phi would be there. Right. So this is not possible. So this is the answer. Okay. Now what about the last one? What about the last one? Again H5 is given. Again H5 is given. So your H5 can either be a function of Jn sin phi. Either it could be a function of Jn sin phi, or it could be a function of Jn dash cos phi. But here what is happening? It is a function of Jn dash sin phi. Are you getting this point? It is a function of Jn dash sin phi. That means what does it mean? That this is also differentiated and this is also differentiated. But it is not possible. Either rho will be differentiated or phi will be differentiated. But here what you are saying, both are differentiated. Is that possible? No. Jn dash and sin and phi, both combined cannot be differentiated. Here also you can see h phi can be a function of Jn rho sin phi or Jn dash rho cos and phi. So both simultaneously cannot be differentiated. So here the answer would be not possible. Is that clear to you? If these kind of questions come in the examination, will you be able to do it in your examination? Say yes or no. You just need to revise the notes. These kind of questions you are never gonna get in any notes on internet. Okay, I am saying on internet, in any notes you are not gonna get, in any textbook you are not gonna get, in any workbook you are not gonna get. Only in this lecture you are getting it, and you need to revise it. That's it. Okay. So I hope this is crystal clear to you how to solve these kind of problems. So these kind of problems are famous for rectangular waveguide. In the examination, I guess for 2 to 3 times they have asked these kind of problem for rectangular waveguide. But circular waveguide has been added recently only. In 2021 only it was added. So I am expecting these kind of questions will come from circular waveguide as well. So in rectangular waveguide we studied the same thing, but we took 2 lectures. Now in this lecture we have covered the things of both of the lectures, right? In this one lecture of circular waveguide we have covered equations as well, and these kind of questions also we have seen. We have studied about TE TM mode as well, and we have seen the basic structure of circular waveguide as well. Now what we need to study? We need to study about the waveguide parameters. So in this lecture only we will study about the waveguide parameters, because that will be very easy. Just some equations will be there. So waveguide parameters we need to study. Then what we need to study? Power calculation. And then what we need to study? Field variations or field patterns. And then we need to see the assignment. So that will be completed. That will complete our circular waveguide. So what we need to study now? Waveguide parameters we need to study. So should we study it in this lecture or in the next lecture? Because this lecture is of roughly around 100 minutes, I guess. So इसमें पढ़ाऊं कि नेक्स्ट में पढ़ाऊं? Let's keep it for the next lecture. Okay, let's keep it for the next lecture. In next lecture, we will study the waveguide parameters as well. We will see the power calculation as well. We will see the field pattern as well. Along with that, we will solve the problems. Okay, so let's keep it for the next lecture. In the next lecture, we are going to see the waveguide parameters. Thank you. Hi everyone. So we were studying about our circular waveguide. Now we need to see the waveguide parameters. So we have seen the field equations for TE TM mode. In this video, we are going to see the waveguide parameters. We are going to see the power calculation. Along with that, we are going to see the field pattern, and then we will solve the problems as well. So these kind of things we are going to do in this particular lecture. So waveguide parameters are very easy. It is similarly like our rectangular waveguide only, right? So let's start. So this equation we already know. This equation is highly used everywhere, and I asked you to remember this one as well, which is this equation: Kc square is equals to gamma g square plus omega square mu e, right? And one thing also we know that when omega is greater than omega c, at that time there will be propagation. At that time there will be propagation, right? When omega is greater than omega c, at that time there will be propagation, and your gamma g will be equals to j beta g. When omega equals to omega c, at that time there will be only oscillations, and your gamma g will be equals to 0. And when omega is less than omega c, there will be no propagation and only attenuation will be there. That means gamma g will be equals to alpha. Alpha bar you can say, or alpha only you can say. Okay. So at omega equals to omega c, what will happen? Gamma g will be equals to 0. That means Kc square will be equals to omega is equals to omega c. So here I can write omega c square mu epsilon. Why we are doing so? Because we need to find the value of cutoff frequency. So what we can see here, omega c is equals to Kc by under root mu epsilon. What is 1 by under root mu epsilon? Vp. So Kc into Vp. This is equivalent to omega c. So what will be your Fc? Fc is Kc into Vp divided by 2 pi. So this is your Fc. This is your cutoff frequency. So which formula we have developed? Cutoff frequency. But the twist is, what is the twist? This Kc value is different for TE and TM mode both. For TE mode and TM mode. So for TE mode, transverse electric mode, and this is your TM mode, transverse magnetic. So transverse electric mode. In transverse electric mode, Kc into A is equals to X dash Np, right? Here we have seen this was our transverse electric mode. So Kc into A was equals to X dash Np. Here you can see Kc into A is equals to X dash Np. How will you remember it? So transverse electric. Okay, transverse electric means Hz is existing. If Hz exists, then directly I cannot apply the boundary condition. I need to differentiate Hz with respect to rho. And if I am differentiating, that means X dash Np will come into action. So this is how you can remember it. Tm. Tm means Ez is existing. If Ez is existing, that means directly I can apply the boundary condition. That means Jn Kc into A, directly I can put that equals to 0. So what will be your Kc into A equals to Xnp. So this is what you can remember for TM mode. So this is how you can remember in the examination, because in the examination there will be a lot of confusion. So what I recommend is that you only remember this Fc formula. And even if you are not able to remember this Fc formula, at least remember this condition. Because if you remember this condition, that Kc square is equals to gamma g square, so at cutoff frequency gamma g will be 0, then omega c square mu epsilon, then in the very next step you can write down the Fc value as well, because that would be Kc by Vp, sorry, Kc into Vp, because mu epsilon will come downward, so Kc into Vp divided by 2 pi. So in 2 steps only, within 10 seconds you will be able to write down the Fc expression as well. So even if you remember this expression, then also it is fine. Even if you remember this expression, then also it is fine. But after that, what will be your Fc value? Because for TE mode, your Kc value is X dash Np by A. So your Fc cutoff frequency for TE mode, that would be X dash Np into Vp divided by 2 pi A. Are you getting this point? And what will be your Fc for TM mode? That would be Xnp Vp divided by 2 pi A. And X dash Np and Xnp, both values are different. What I mean to say is that X dash 11 and X11, Here NP value are same. Here NP value are same. NP value is 1 1. NP value is 1 1. But x dash 1 1 and x 1 1 both will be different. If you remember the table, there we have seen that both will be different values. So in case of rectangular waveguide, in case of a circular waveguide, the cutoff frequency for TE and TM modes are different. But in case of rectangular waveguide, the cutoff frequency was Vp by 2 under root m by a whole square plus n by b whole square, which was working for both TE and TM. But here the formula will be different. Which formula can work for both of them? This formula can work for both of them. But when you write down the value of Kc, because the Kc value for TE mode and TM mode are different. For TE mode it is x dash np by a, and for TM mode it is x np by a. How will you remember? TM mode, that means EZS is existing. If EZS exists, then I don't need to differentiate the Bessel function. If I don't need to differentiate the Bessel function, that means x np would come. Otherwise x dash np would come. This is how you can remember. So these are the formula. Okay. What do you think? What will be the formula of lambda c? So lambda c will be simply equals to Vp by Fc. That's it. So if you do Vp by Fc, what we are getting? 2 pi by Kc. So this also you can keep in mind, and then Kc value you can put as per the TE TM mode. Okay. So here only I am writing TE and TM mode. So for TE mode, lambda c would be 2 pi by x dash, TE mode it is, no? Yeah, so for TE mode it would be x dash np only, x dash np by a. And if I talk about TM mode, then lambda c would be 2 pi a divided by x np. Do I need to remember it? Do I need to mug it up? Absolutely no. So from this slide, only if you remember this expression. So from this slide I am marking, from this slide I am marking star only on this one. So if you remember only this expression, then within seconds you can write down all these things. Within seconds. If I remember this expression, then directly I can write down this Fc value very easily. And if I write down Fc value, then Kc value I need to write down for TE and TM mode. For TM mode, x np would come, and for TE mode, x dash np would come. That's it. And if I need to write down lambda c, so that would be very simple, Vp by Fc, because lambda is equals to Vp by F. So lambda c will be equals to Vp by Fc. So directly I can see Vp value I know, Fc value I know. So very easily I can write down all these expressions. Do you agree to my point or not? Certainly you agree to my point, right? Okay. Let's go to the next one. Guided phase constant. So what that would be? Beta g. Same expression, ditto same expression. When you do the derivation, you get to know the same expression you are getting, but the condition is here, omega should be greater than omega c, or you can say f should be greater than fc. So when you do the derivation, you get the ditto same expression. So again, derivation is not required. If you want to do, you can do it on your own, very easy. From here, you just need to do the derivation in the same manner. So beta g you get beta into under root 1 minus fc by f whole square, the same formula. Now if I tell you one statement, you need to tell me whether it is true or false. Okay, I am telling you one statement, you need to tell me whether it is true or false. Okay, so what I am saying is that for circular waveguide, the expression of guided phase constant is same for both TE and TM mode. What I am saying, for circular waveguide, the expression of guided phase constant is same for TE and TM mode. Is that correct? This expression will work for both TE and TM mode, that I am saying. Both TE and TM. But in TE and TM, FC value will be different, no? FC value for TE mode will be different, and FC value for TM mode will be different. So beta g value will be different for both of the modes. Are you getting this point? In case of rectangular waveguide, beta g was equals to beta under root 1 minus fc by f. Same formula was there. But there fc was same for TE and TM. But here fc is different for TE and different for TM. So beta g will also be different for TE and different for TM. So in one liner, these kind of questions can be asked. Then in case of rectangular waveguide, beta g expression will be same for both of the modes. Yes. But in case of circular waveguide, it will not be same. Although the formula is this only, beta g equals to beta into under root 1 minus fc by f. But the fc value is different. Beta value is same for both of them, f value is same for both of them, but fc value is different. So if fc value is different, then the beta g expression will also be different. And what about lambda g? Lambda g will be equals to lambda upon under root 1 minus fc by f whole square. So this will be your lambda g, or you can write down lambda g as lambda g is equals to lambda upon under root 1 minus lambda upon lambda c, because lambda is inversely proportional to f. So lambda upon lambda c whole square. And when you solve this, you get this thing. So this expression is ditto same. What I need to do is that I will take 1 by lambda upon lambda c this side, and lambda upon lambda g whole square will be on this side. Now what I need to do, I need to divide by lambda square. So if I divide by lambda square, 1 upon lambda square is equals to 1 by lambda c square plus 1 by lambda g square. So same expression is applicable here as well. So this expression is applicable for both circular waveguide and rectangular waveguide as well. So all the expressions are same. Just the thing is this FC is different. FC is different for TE and TM mode. So this you need to take care. That's it. Nothing else. Is that clear to you? Let's move to the next slide. Tilt angle. What was the tilt angle? So cos theta t was equals to under root 1 minus fc by f whole square, right? And one thing also I know that theta is plus theta t is equals to 90 degree. What about intrinsic impedance? So intrinsic impedance for TE and TM. So with the team you need to stand. So with the team you need to stand. So that would be 1 minus fc by f whole square. And for TE, t can go downward. So under root 1 minus fc by f whole square. All the formulas are same. Just the fc value will be different. The only thing is fc value will be different for both of the modes. What about phase velocity? Phase velocity. So for phase velocity, the expression will come downward. 1 minus fc by f whole square. So these formulas are working for both of the modes, right? For TE mode as well, for TM mode as well. So these formula we are writing for both of the modes. The only thing is this fc value is different for both of the modes, right? What about the guided phase velocity? So that would also be Vp into 1 minus fc by f whole square. Okay. And one thing here also, Vpg into Vgg is equals to Vp square. And here also you can write down the relations that beta g will be less than beta, lambda g will be greater than lambda, and this you here neta te will be greater than neta, neta tm will be less than neta, vpg will be greater than vp. How I am writing down all these things, you should be comfortable with that. Why is that so? Because we have spent a lot of time in rectangular waveguide in writing down all these things. Vpg will be greater than vp and vgg will be less than vp. Okay, well and good. Dominant mode. Let's see that dominant mode now. Dominant mode means the mode having lowest cutoff frequency. This slide, these two slides are clear, right? Fc value is different for both of them. Then I know beta g, lambda g, all these expressions are same, just the fc value will be different. Then cos theta t, then neta for TE and TM mode both will be different only. So these expressions we get. Then guided phase velocity, guided group velocity. Then dominant mode now we are checking. So for TE mode, what you are going to get? Cutoff frequency for TE mode. This is the general expression of cutoff frequency, right? Kc into Vp divided by 2 pi. So for TE mode, what is the expression we are getting? For TE mode, it would be x dash np into Vp divided by 2 pi a. And for TM mode, it would be x np into Vp divided by 2 pi a. So this is TE mode, this is for TM mode. This also FCTE I am writing down. Now if I need this to be minimum, that means what I will require? Look, this A is constant, this is the radius of your circular waveguide. This is the radius, this A is constant, right? Yeah, Vp is also constant, like this will be the phase velocity. 2 pi is also constant. 2 pi a Vp, everything is constant. Now all the things will be depending on this x dash np value. All the things will be depending on this XNP value. So if I need this expression to be minimum, if I need FC to be minimum, then I need the minimum value of X dash NP. And here I will require the minimum value of XNP. Say yes or no. And if you remember the table, what is the minimum value of XNP? That is 2.405. The minimum value of XNP, that is 2.405. And what is the minimum value of X dash NP? That is 1.841. I asked you to remember these two values. In the last lecture, I asked you to remember these two values, right? So minimum value of X dash NP is 1.841 and minimum value of XNP is 2.405. So what do you think, which mode will have the lowest cutoff frequency? So basically here your FC is coming out to be, and for which value of NP this you are getting? This value you are getting 1.841 for which value of N and P? So the value of N is 1 and the value of P is 1. The value of N is 1 and the value of P is 1. And for which value of N and P you are getting this thing? So here the value of N is 0 and P is 1. The value of N is 0 and P is 1. So here your FCTE11 would be X dash NP is 1.841 Vp divided by 2 pi a. And here your FC TM01 that would be 2.405 Vp divided by 2 pi a. Which value is smaller? This value is smaller or this value is smaller? Which value is smaller? This value is smaller. That means this is the lowest value of a cutoff frequency in circular waveguide. Lowest possible value. Value of FC. Right? Because value of FC is depending on this X dash NP and XNP. Now what is the minimum value of X dash NP and XNP? So from this table we get to know that minimum possible value is 1.841 and that you are getting for X dash NP. For X dash NP. That we are getting for X dash NP. And at what value of N and P? At 1, 1. N is 1 and P is 1. So our dominant mode in case of circular waveguide is TE11. Our dominant mode in case of circular waveguide is TE11. Are you getting this point? And this is our cutoff frequency for TE11. But what we can do is that, how Vp can be replaced? Can you replace Vp as C under root mu r epsilon r? Say yes or no? Because what is Vp? Vp is omega by beta. And what is beta? Omega under root mu epsilon. So Vp is under root mu epsilon. And when you take mu naught epsilon naught outside, what you get? C under root mu r epsilon r. So this derivation very easy, we have seen already. So Vp can be replaced with C upon under root mu r epsilon r, right? So 1.841 into C, which is constant, which is 3 into 10 to the power 8, divided by 2 pi into A into mu r epsilon r. So if you solve it, what do you get? The cutoff frequency for dominant mode. So this value I know, 2 pi I know, these value also I know. So what do I get is that 8.8 gigahertz divided by A under root mu r epsilon r. So this expression I get. So this is the FC value I get, where A should be in centimeter. Very important point. I am assuming that my A is in centimeter, then I am getting this expression. When I solve this thing, then what do I get? 8.8 gigahertz. That means I am getting 8.8 into 10 to the power 9. Actually, I get 8.8 into 10 to the power 7 only. When you solve this much of quantity, you will get 8.8 into 10 to the power 7. You can do it in your calculator. But I am assuming that my A is in centimeter. That means let's just say A is given as 2 centimeter. So here I will write 2 into 10 to the power minus 2. Then what will happen? This 10 to the power minus 2 will go upward. So what you will get? 10 to the power 9. So now in this expression, if I need to write down the value of A, let's just say value of A is given as 2 centimeter. So in this expression, what I'm going to write down? 8.8 gigahertz divided by 2, and let's just say mu r epsilon r is 1 only. So this will be my cutoff frequency of dominant mode. So here I'm not going to put 10 to the power minus 2, because already this minus 2 I have taken up in giga. Are you getting this point? So 99.99% chances are there that the radius will be in centimeter only. It will never be in meter. So if I already know that it will be in centimeter, then why should I waste my time? That why should I write down 8.8 into 10 to the power? What I could have done is that I could have written down this expression as this: 8.8 into 10 to the power 7 A mu r epsilon r. Now I don't need to tell that whether A is in centimeter or meter. So by default you take it to be in meter. So what you would have done? 8.8 into 10 to the power 7. Then let's just say A is 2 centimeters. So 2 into 10 to the power minus 2. Then mu r epsilon r. Let's just say these are 1 only. So forget about it. So what do you get? 8.8 into 10 to the power 9. That means gigahertz divided by 2. So 4.4 gigahertz. So A will be mostly in centimeter only. So that's why that centimeter I have already taken upward and I have made it 10 to the power 9. So this is my 8.8 gigahertz where A is in centimeter. Is that clear to you? We will solve the problem. It will be more clear to you. So now till this point, what is the conclusion? Till this point, here we have seen that dominant mode we were seeing. So in dominant mode, we need to get the lowest cutoff frequency. So we write down the formula of cutoff frequency for TE and TM mode both. Then we go to know that it is depending on X dash NP and XNP. Minimum value of X dash XNP is 2.405 and minimum value of X dash NP is 1.841. That means the lowest cutoff frequency is certainly for X dash NP. That means for TE mode you are getting lowest cutoff frequency. And what are the value of N and P? N value and P value are, both are 1. So TE11 mode is our dominant mode. And we are having this table as well. From this table we got to know. But what we need to remember, the minimum value of X and P is 2.405 and that you get for N equals to 0 and P equals to 1. This you can keep in your mind if you are able to keep it in your mind. But at least remember that dominant mode for sure. At least remember that dominant mode for sure. The dominant mode is TE11. Is that clear to you? Right? So cutoff frequency we wrote down, and then we saw that Vp we can replace with C upon under root mu r epsilon r. So from there we got to know that my FC value could be 8.8 gigahertz, 8.8 gigahertz upon A, and then under root mu r epsilon r should also come there. So this also you can keep in mind. If you are not able to keep in mind, then at least keep this in mind. Because there is very high chance that for dominant mode, at least they ask you to remember the value of X dash and P. For dominant mode, at least you need to remember 1.841. So this is very, very important. Here I am putting 2 star. Even if you are not able to remember this one, but at least you need to remember this one for sure. Okay. Now there is another term that is known as degenerate mode. What do you mean by degenerate mode? That means modes having same cutoff frequency. Modes having the same cutoff frequency. So in circular waveguide, TE0P and TM1P both have the same cutoff frequency. Why is that so? Because what is your FC only depends on X and P for TM mode, and FC only depends on X dash and P for TE mode. Right? Now you see one thing. What do you see? TE0P, TE0P, this table, and TE0P, this is the table of X dash and P. So TE0P, this table, and TM1P, this table. You see both of these table. This is the table of TE where N is 0 and P is changing. And this is the table of TM1P. Why I have written TM mode here? Because these are the roots of X and P. These are the roots of X and P, and X and P is associated with TM mode. And X dash and P is associated with TE mode. So if you see this one, TM value of N is 1 and value of P is varying. So both of the table are same. TE0P and TM1P, both of the tables are same. And for 3 as well, for 4 as well, the table is always same. So what do you understand by this? That cutoff frequency will be same for TE1P mode and TE-OP mode. That means if someone is saying that cutoff frequency for TE, not OP, it is 0P, sorry. It's not OP, it is 0P. So FC for TE02 mode is given like let's just say 2 GHz. Then if they ask FC for TM12 mode, what that would be? That would also be 2 GHz, because 0P and 1P, TE0P and TM1P, both are having the same cutoff frequency. Okay, and how do I remember it? So TE sounds as T, right? And if you use social media, so you must have heard this term OP, overpowered. Like in in some streamer you use this word, right? Some streamers use this word OP, overpowered, like your content is OP, right? So OP word you have already seen. So T is always OP, no? I guess you all guys, most of you guys are tea lover. They always drink tea. I also always have tea, which is not good actually, but always tea is always OP. So T is always OP. And what about our team? What about our team India? So team India is depending on only one player, and that is Jasprit Bumrah, right? I only believe in Jassi Bhai. So our team India is only depending on one player, that is TM1P. Our team depends on only one player and T is OP. This is how I remember it. Degenerate mode. At that time, our team was depending on Virat Kohli, so there I took the reference of Virat Kohli. But now our team is depending on Jasprit Bumrah. So here I am saying that my team is depending on one player and my T is OP. Both are degenerative mode. So this is how you can keep in mind. Okay. So what do you understand by this thing is that this is how I can keep in mind, and the meaning of degenerative mode is that, what is the meaning? That cutoff frequency for T is OP and cutoff frequency for TM1P is equal. This is known as degenerative mode. And how did we verify it? Using the table. So they can ask you which of the modes are degenerative. That means you need to check 0P and 1P. 0P in case of T and 1P in case of TM. And will you be able to remember this thing, that T is associated with X dash and P? How will you remember? How will you remember? TE means electric field is transferred. That means HZ is existing. If HZ is there, then to apply the boundary condition, you need to do the differentiation. If differentiation is done, that means X dash and P will be used. That's it. This is how you can remember it, right? So the thing is, we are studying the formula, but certainly we are developing a method to remember the formula as well, because that is more important. Formula everyone will write down. Everyone will write down formula, everyone will derive it. But there should be a trick, there should be a way to remember the formula in longer run. Because in longer run, you are going to forget all these things. But if you remember in this manner that I am telling, you are never going to forget it. Right? So that's why I asked you to remember this step. Which step? This step. If you just remember this step, then most of the job is done. You can derive FC value. If you can derive FC value, then you can solve a lot of problems. Because in all the problems you require FC value, FC value, FC value. Everywhere you require FC value. In all the formula you require FC value. Right? We will write down the summary now. All the points we will write down. But let me take a break. You can also revise it. And all the formula you can write down on your own. In your rough notebook, write down all the formula on your own. And then just match it. Okay? Yeah. So I will take a pause. You can also take a pause. Okay. So let's write down the summary. So this point I always ask you to remember that Kc square is equals to gamma g square plus omega square mu epsilon. Right? What was your FC? What was your FC? So from here only you can see that it would be Kc into Vp divided by 2 pi. Now for TE TM mode it will be different. So let's write down 4 different modes for TE mode and TM mode. So in TE mode it would be FC for TE mode would be, what will be your Kc? Kc will be for TE mode, transverse electric mode. That means the magnetic field is existing. And if magnetic field is there, that means you need to differentiate. And if I need to differentiate, then X dash NP by A. So it would be 2 pi A X dash NP by A into Vp. And if I need to write it down for TM mode, then in TM mode EZS is existing. So directly I can write down divided by 2 pi a. What about beta g? Beta g will be beta into under root 1 minus fc by f whole square. But I know that my cos theta is 1 minus under root fc by f whole square. So better I will write down beta cos theta t, where theta t is the tilt angle. What about this lambda g? So lambda g is lambda upon cos theta t. What about this vpg? Vpg is vp upon cos theta t. What about this vgg? That is vp into cos theta t. This expression is also there. How do I remember it? Here there is no subscript, and those who are having the subscript, they will be on the right hand side, and the one this will be in left hand side. What about this neta te? So neta te. So with team you need to stand. So neta into cos theta t, and for te, neta divided by cos theta t. Right. Dominant mode is TE11 mode. Degenerate mode are your T is OP and your team is depending on one player. So T is depending on one player. What about FC? What about your cutoff frequency for TE11 mode? So for that we developed the formula 8.8 gigahertz divided by A, and if the medium is some other dielectric medium, then under root mu r epsilon r would also be there. So this was the formula of FC, but with the condition that A is in centimeter. So 8.8 gigahertz divided by A under root mu r epsilon r, condition that A is in centimeter. And what are the known existing mode? P value can never be 0. So N0 and TM N0, right? So P value can never be 0. Now let's see the power transfer. So the same topic we have seen in our first we saw that this topic in EM wave propagation, then we saw this topic in transmission line as well, then we saw this topic in our rectangular waveguide as well. Now we are seeing it in circular waveguide as well. So what will be your time average pointing vector? What is this P average? That is time average pointing vector. Time average pointing vector. So what is the formula that we have developed? E naught square divided by 2 neta. So 1 by 2 neta. Here neta will be depending on the T mode. So neta G I am writing. So neta G could be neta TE as well, neta TM as well. Neta G could be your neta TE or neta TM. So depending on the mode that is given, you will write down the neta G value. 1 by 2 neta G. But from this particular topic, the question will not be asked in the examination. Why is that so? I will tell you. So E naught square. Now in place of E naught square, what will happen? There are two components. E rho s component is there plus E rho s component is there and E phi s component is there. So this will be your P average formula. What could be the other one? The other formula was 1 by 2 neta H naught square. So 1 by 2 neta G. Neta G could be neta TE anything. And here as well we are having two components, H rho s plus H phi s. Right. So these are the two formulas of our time average pointing vector. Time average pointing vector. So these are our two formula. Let's remove it off, and neta G is neta TE and neta TM. What about the total power? What will be the total power? Total power will always be P average into ds. So here what will be our ds if you remember? And yeah, I forgot to tell the direction AZ gap, because wave is propagating in Z direction. So it will be carrying the power in Z direction. So AZ gap. Now P average I am writing with respect to E expression. Okay, with respect to H expression also you can write down, but I am writing with respect to E expression. So let's write down for both of the expressions. So what is your P average? So integration P average is 1 by 2 neta G E rho s plus E phi s. Now if I need to write down ds, what do you think what will be my ds? If you have studied in a good manner, then you know that it would be rho d rho d phi, where the limit of rho will go from 0 to a and the limit of phi will go from 0 to 2 pi. If you have seen the coordinate system, then you would be able to know, right? Because P average is having the direction of AZ gap. So ds should also have the direction of AZ gap. So in AZ direction, what is your area? Rho d phi, right? And similar thing you can write down here also, 0 to a, and pi will go from 0 to 2 pi. Similar thing you can write down for our H field as well. So 1 by 2 into neta g, here neta g, H rho s plus H phi s, rho d phi. Now the thing is, in rectangular waveguide we wrote the expression for dominant mode. The expression was coming out to be E naught square divided by 2 neta into a by 2 into b. This was the total power carried. This was your P total in dominant mode for rectangular waveguide. But here we are not writing it down. Why is that so? Because you require the, in this case, you require the integration of your Bessel's function. In this case, you require the integration of your square of Bessel's function. No? Say yes or no? Because there what you will write down, you will write down E rho as expression. So there Bessel's function will be there. So that integration you require. You require the integration of Bessel's function. And we do not know the integration of Bessel's function. This is not in our syllabus. And honestly, I also don't know how to integrate a Bessel's function. Also, there will be square as well. So I don't know how to integrate a square of Bessel's function. So there is 0.01% chance that they can ask power calculation question in circular waveguide. Certainly they can ask in rectangular waveguide. But 0.01% chance that they can ask in circular waveguide. But even if they are asking, they will mention the value of this integration. But it will be very hectic task for them. So I don't think they will ask any question on power calculation in circular waveguide. What is the reason? Because you need to do the integration of Bessel's function. And that is not in our syllabus. In M.tech as well, we never study it. So integration, we don't know how to do the integration of Bessel's function. So this is the only discussion which I want to do in power calculation. There could be more discussion, but that would require the integration of Bessel's function. So there is very rare chance that they will ask this question in your examination. Okay. So P total formula for dominant mode in case of rectangular waveguide we remember, but here we don't need to remember any formula. We just need to know the method. In worst case, if they ask you the questions, then you should have the ability to solve these kind of problems. In worst case, if they mention all the values, like a lot of values, if they mention like H rho s value, they mention anyhow, they give the value of integration as well, and then they are asking the total power, then you should have the ability to apply this formula and get your answer. But there is very rare chance that any question would come up, right? And even if it comes up, then there is high chance that using this formula, certainly you will be able to solve that. Well and good. Let's see the field patterns. So do you remember the field patterns in our rectangular waveguide, right? So same thing we need to see in our circular waveguide as well. So in rectangular waveguide as well, there is one question on field pattern. There is one question on field pattern till this date. Till this date in GATE examination, there has been only one question on field pattern in rectangular waveguide. And in from circular waveguide, okay, now I can tell you this thing. So from circular waveguide till this date in GATE examination, no question has been asked from circular waveguide. No question has been asked from circular waveguide. I am not talking about field pattern. I am talking about the complete circular waveguide. No question has been asked. So if they are asking the question on circular waveguide, so first they will ask easy question, like they can ask the value of beta g, lambda g, these kind of questions they can ask, or they can ask the question on field patterns. These field patterns we studied, right? Sorry, not field patterns, sorry, these field expression we studied. These kind of questions they can ask, or they can ask these kind of questions that they can ask you apply these formula, or they can ask the cutoff frequency. So there is very rare chance that field pattern question will come up in your examination. So this is I am telling. So don't take much pressure of this. Again I am telling that it is very rare that 0.01% chance is there that they will ask any question from field pattern. They don't even ask a field pattern question from rectangular waveguide, but in syllabus it is mentioned, so we have to cover it. But very rare chance that question may come up. So certainly I will tell you a method that how to recognize the field patterns, and using that method you can tell your answer. But don't take much pressure of this. There is very rare chance that it will come in your examination. But certainly we need to study it. Hardly it will take you 5 minutes to revise this topic. To understand it, it may take 15 to 20 minutes, but to revise it, it will take hardly 5 minutes, right? So let's start. We need to study the field patterns. So n and p value are there. You know what is the value of, what is the meaning of p, what is the meaning of n. So I don't need to repeat it. Just I have written down the value of n. What was your n? Your n was number of full cycle in pi range, 0 to 2 pi range. Number of full cycle in 0 to 2 pi range. Or what you can say, number of half cycle in 0 to 2 pi range divided by 2. Because what I mean to say is that in 0 to 2 pi range, if there are 1 and 2, this is your 2 pi. Let's just say this is your 2 pi. So here you are having 2 full cycle and 4 half cycle. So in 0 to 2 pi range, you are having 4 half cycle divided by 2. So that is the value of n. So n is 2. Are you getting this point? Either you calculate full cycle or you calculate half cycle divided by 2. So that is your n. So this is just I wanted to tell you. And what kind of field we will have? TE, NP and TM, NP. These two kind of fields we will have. So let's see the field patterns. So first you let me know, just by looking at this, what you can see. Here you can see the half cycles. So whenever you can see the half cycle, that is TE. Here can you see the half cycle? So whenever you can see the half cycle, that is TE. Let's drop this one, let's drop this one. Here can you see the dots? So these things we have already seen in rectangular waveguide. So can you see the dots? Yes. Then it would be TM. Let's go to the next slide. Can you see the half cycles? Yes. So it would be TE. Can you see the dots? 1, 2, 3, 4, 5, 6. So it would be TM. Can you see the half cycles? These are half cycles only. Look, these are separate nodes. These are the nodes from where the H field lines are going out, because here here solid line is E field. Solid line is E field and dotted line is H field. You will not say that, sir, these are the dots. No, dots are different only. If you see this structure, here these dots and these dots look different, right? Here there is circulation around this dot. If I say this is a dot, so here there is circulation. But in this dot, what is happening? The field lines are getting out. From this circle, the field lines are getting out like this. But here around this circle, there is circulation. So both are different. It is, you can say it is acting as a source. These are acting as a source. Like just to tell an analogy. I am just telling an analogy. So these are acting as a source. No, these dots are acting as a source. But here you will not call that, sir, here there are 4 dots. This is also a dot. No, these are not dots. Because around these dots there is circulation. But from here the field lines are getting out. So those dots I need to take where the field lines are getting out. So this is your TM. Here you can see the circulation. This is also circulation only. You can see the circulation. On boundary you can see the circulation. So these are also circulation only. So here you can see the circulation. So this is your TE. What about this one? Do you see any dots here? No. Here you can see the circulation. So this is also TE. This was your TM. Now here also this is a circulation only. This is a circulation only. So these are your circulations only. This is circulation only. So here also you can see the circulation. So this is TE. So directly in this case as well, when we were studying about a rectangular waveguide, so there also we could see the dots and field lines were getting out. Field lines were getting out like this. So directly you can differentiate. If you see this diagram, you can see that field lines are getting out. This is TM. Field lines are getting out. This is TM. Here directly you can see this is TE because on the axis, on the boundary, I can see the half wave cycles. So that would be TE. In TM, here the field lines are getting out. Here there could be confusion. But you see that if I take this as dot, then there is circulation around this dot. Field lines are not spreading out. Are you getting this point? Okay. So this is your TE mode only. Now I need to tell the N and P values. Okay. So first tell the N value. What will be your N value for TE case? What is your N? Let me erase it. N is the number of half cycle divided by 2. So let's just say if I say this is phi equals to 0, then what will be phi equals to 2 pi? The complete circle will be phi equals to 2 pi. So from 0 to 2 pi if I am going, then I am working on the complete circle. So on the complete circle, how many half cycles I am getting? 1, 2, 3, 4. So 4 half cycles I am getting. So what will be the value of N? For this case, what will be the value of n? 4 half cycle I am getting, but I need the full cycles. So there are 2 full cycles. So TE2. Are you getting this point? Here, how many half cycles are there? 1, 2, 3, 4, 5 and 6. 6 half cycle, that means 3 full cycles. Because in 0 to 2 pi, I need full cycle. Number of full cycle in 0 to 2 pi. But I am calculating the half cycle. So half cycle is 6, then full cycle is 3. P value also I will tell, but wait a minute. Here, how many half cycle I can see? Only on the boundary I need to check. You will not say that, sir, this is a half cycle or full cycle. No, only on the boundary. So this is one half cycle and this is another half cycle. If you see this diagram carefully, then here this is also a circle only, one half cycle. I should not say circle, this kind of structure is there. So this is one half cycle, this is another half cycle. So there are 2 half cycles. There are 2 half cycles. So one full cycle is there. So TE1. What about this one? One half cycle and one half cycle. So how many half cycle are there? 2. So 2 by 2, one full cycle is there. Now I need to tell the value of P. So how do I tell the value of P? So from boundary, how many kind of circle you can see? How many circles you can see? From boundary, how many circles you can see? Only one kind of circle I can see. No? Here also this is one kind of circle, one kind of circle. So from here if I start, only one kind of circle I can see. So value of P is 1. Here also only one kind of circle I can see. Value of P is 1. Now there is confusion. Now here the confusion will be gone. So this is one kind of circle. You can say this is one kind of structure. If I start from here, this is one kind of structure I can see. Then here another structure I can see, which is this one. So 2 structure I can see. Look, if you go by definitions like this is the meaning of N and P, then how will I determine the TE and P value? If you go by the definition, then it will become very tough for you. I can guarantee it. But if you just go the way I am telling it, then you will be able to write down the value for sure. What I told, first you calculate the number of half cycle. 4 by 2, 2. 6 by 2, 3. And 2 by 2, 1. 2 by 2, 1. Then how many circles you can see? Here you started, only one kind of circle I can see. From any node I can start, only one kind of circle I can see. From here if I start, one kind of circle and 2 kind of circle. So 2 kind of circle I can see, so this is TE12. So here there are n value is 1, but 2 kind of circle, so TE12. Here how many kind of circle I can see? Only one kind of circle. This is one kind of circle only. So from all the end you will not start. You will only pick one of the end. Let's just say I have picked this end. I have picked this end. So from here I will start. So only one kind of circle I can see. So this is TE11 mode. How did I get the value of n? That you understood. Then on the boundary you need to check the half cycles. If I check the half cycle divided by 2, that will be the value of n. In case of a rectangular waveguide, if this was the structure in rectangular waveguide, then what we used to check, how many half cycles are there on y-axis, how many half cycles are there on x-axis. So this would be, how many half cycles are there on x-axis? 2. How many half cycles are there on y-axis? 2. TE22. This is how we used to tell in our rectangular waveguide. In rectangular waveguide, if this was the case, let's just say if this was the case, then how many half cycles are there on x-axis? 1. How many half cycles are there on y-axis? 2. So this was TE12. This is how we used to check in our rectangular waveguide. But in circular waveguide, things are different. N and P we need to check. So for n value, what did we show? In 0 to 2 pi, how many half cycles are there? 4. 4 by 2, 2. 6 by 2, 3. And 2 by 2, 1. Now I need to check the value of P. So how will I check that how many kind of circle I can see? Only one kind, one kind, one kind and 2 kind. So 1, 2. Here also one kind. Let's go here. How many half cycles you can see? 1, 2, 3. We are starting from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 half cycle I can see. So value of n will be 8. How many kind of circle I can see? Only one kind of circle. Like there is not another circle here. There is no another circle here. So only one kind of circle I can see. T81. Tell about this on your own. So how many half cycle you can see? 1, 2, 3, 4. So value of n is 2. How many kind of circle you can see? One kind of circle, 2 kind of circle and 3 kind of circle. T23. That's it. Is that clear to you? Will you be able to tell? Right? No issue. So this is all about our TE. let's talk about TM now. Okay, so just a minute, I will pause a bit because I have some work to do, then I will come back. Yeah, so let's start for TM modes now. Okay, yeah, so in TM mode, what you need to do, you will see that field lines are getting out from here. So these two dots are there. Here there are 4 dots. So how many dots are there? 2 dots are there, right? So value of n will be 2 dots are there divided by 2. Value of n will be 1. How many dots are there? 4 dots are there. So 4 by 2, value of n will be 2. How many dots are there here? Dots are 1, 2, 3, 4, 5, 6. So 6 by 2. This is just a problem solving method, nothing else. I am not teaching any concept here. Just I am telling if the field pattern is made, how will you recognize that which mode is that? That's it. If you want the concept, then you can search for n number of things. You will never understand the concept here. Okay, this is the reality. Because it is very tough to visualize these fields. But if they have made the pattern, because these kind of things are given in the textbook. So if they have made the pattern and if they have asked you that what kind of field pattern is that, then you cannot do anything there. You have to tell. So what is the value of n? Here, how many dots you can see? 1, 2, 3, 4, 5, 6. 6 by 2 is 3. Here, how many dots you can see? 1, 2, 3, 4. So 4 by 2, 2. Here, how many dots you can see? 2. 2 by 2, 1. Right? Now, value of p you need to determine. So that is very interesting. So how many spaces I can see here? These are 2 spaces, right? 1 and 2 spaces. So from these 2 spaces, how many circles can pass? 1 circle can pass, no? From these 2 spaces, 1 circle can pass. So value is 1. So from all these 4 spaces, how many circles can pass? 1 circle can pass, no? Value of p is 1. Here if you observe closely, so these are the spaces. From these spaces, 1 circle can pass, right? But there is another space. This is another space. From these another space, another circle can pass. There is this another space. If another space is there, so another circle can pass. So 2 circles can pass. So this is TM32. What I did here is that I saw the dots 1, 2. So n value is 1. 1, 2, 3, 4. N value is 1. Now someone will say that, sir, these are also dots. No. In dots, what is happening? From here also field line is going out. Here also field line is going out. Here also field line is going out. So from everywhere field lines is going out. But if you talk about this dot, so from here field lines is coming in and from here it is spreading out. So these are not those dots. So for defining the value of n, only you need to look at these dots from where all the field lines are getting out. So from this dot, all the field lines are getting out. Right? So 1, 2, 3, 4, 5, 6. 6 dots are there. So TM3. Now how many circles you can make? So 1 circle, then there is another space. So another circle I can make. So 2 circles I can make. So TM32. This is the way. Is that clear? All these are clear. Let me repeat it once again. It is not tough. Just you need, you just need to revise it. Nothing else. So whenever you see that I can see the field pattern on the axis, then it is TE. Here I cannot see any field pattern like that. So this is not TE. Here I can see the dots. This is my TM. Here I can see the dots. This is my TM. Here I can see the patterns. Here I can see the pattern. This is my TE. Then value of n. If I need to tell the value of n, then what I need to do? Number of half cycle. 4 divided by 2. 6 divided by 2. 2 divided by 2. 2 divided by 2. That's it. Here 16 divided by 2. And here 4 divided by 2. So T2. Now if I need to tell the value of P, then from here if I start, from any end if I start, how many kind of circle I can see? 1 kind of circle. 1 kind of circle. 2 kind of circle. So value is 2. Here 1 kind of circle, value is 1. Here 1, 2, 3 kind of circle, so value is 3. Is that clear? Now coming to TM, 2 dots I can see, 2 divided by 2, that is the value of n is 1. 4 dots I can see, 4 divided by 2, value of n is 2. 1, 2, 3, 4, 5, 6. 6 divided by 2, value of n is 3. If I need to tell the value of P, then what I need to see? From these 2 dots, 1 circle can pass. From these 4 dots, 1 circle can pass. From these 6 dots, 1 circle can pass, but there is another space as well. So from there as well, another circle can pass. So TM32. Actually, this is the point of minima. Like here, there is one minima here, another minima here. So that's why the value of P is 2. Because what does P represent? Number of minimas. So that's why P is 2. Here there is only one minima, which is this one. So value of P is 1. Here only there is one minima. Value of P is 1. Like this is symmetric, no? So you will say only one minima. You will not say that, sir, here there are two minima. No. One minima only there. Here also there is one minima. But here one minima and then another minima. That's why value of P is 2. And in this case, what I was saying about the circles. So here there is only one minima. This is the minima. Here only there is one minima. Only one minima is there. But here, if two circles are being separated, that means one minima is there and another minima is here. So there are two minima. That's why value of P is 2. So don't get confused with minima and all those things. Because if I had told you about the minima, then you would be getting confused. So better, what you remember, one kind of circle, one kind of circle, two kind of circle, one kind of circle, right? And from dots, how many circles I can make, how many circles I can make, how many circles I can make. That's it. So this is how you can determine the field patterns. Is that clear to you? Again, you can watch the video. Again, it will be clear to you. Okay, once more you can watch, and it should be all clear to you. Now, one more thing is left. What is that? Determining TEOP and TMOP. Like here, we saw a lot of example, but anytime n was not 0. What if n is 0? Here, n was not 0. P can never be 0, right? P can never be 0. But n can be 0, no? But here n was not 0. Anywhere n was not 0. So now I need to take the case where n is equals to 0. So if n is 0, then how will the field pattern look like? So here if you see this pattern, this pattern, this pattern, all looks like the same. That from a dot, field lines are spreading out. So here you can see some like lines like this, some radial line you can see, and some circles you can see. So if the circles are made from E field, then it is circles are made from E field, then it is TE. And if circles are made from H field, then it is TM. And what did I tell you? Your dashed line is E field. This will be given in the examination. Okay, do not worry about it. And your dotted line is H field. So if you see that from a source, from a middle point, like there are circles spreading out. From a middle point, circles are spreading out. Circles are spreading out. Circles are spreading out. Then certainly n value is 0. There is no doubt about that. Now, if you need to determine whether it is TE or TM, then what you will see that here circles are made from dotted line. And what is dotted line? H field. So that means circles are made from H field. That means it is TM. Here circles are made from which line? Circles are made from your strong line, or you can say, just a second. Just 1 second now. Yeah, so what I was saying, here circles are made from, what I am writing, here circles are made from E field, right? Circles are made from solid line. Circles are made from solid line. So if circles are made from solid line, that means it would be TE mode. Here circles are made from dashed line, that means it would be TM. And here circles are made from solid line, that means it would be TE. So you need to see, one thing you need to see is that from a source, circles are spreading out. Here circles are spreading out, circles are spreading out, circles are spreading out. That means this is the case of n equals to 0. N equals to 0. So this is the case of n equals to 0. Now you need to check whether it is TE or TM. So if field lines, if these circles are made from H field, then it would be TM. And if it is made from E field, then it is TE. So here circles are made from H field. Why is that so? Because circles are made from dotted line. Circles are made from dotted line. So these dotted line are your H field. And these solid line are your E field. These are your H field. And these are your E field. So circles are made from E field, then TE0, TM0, TE0, TM0. Now what I need to check? I need to check the value of P. So how I will do it. So here in between I can see one circle. Like in the space I can see one circle. So here there is only one circle, no? One circle possible. In the space, in the open space, there is only one circle possible. So P value is 1. Now you are getting confused, I know. But let's see here. So here I can see one circle here, right? Then between this circle and this circle there is huge space. If you see clearly, between this circle and this circle there is huge space. So another circle I can make in between. But here all the circles are continuous. The space is continuous. The space is continuous. So in between you cannot make another circle. But here if you see that the space between these two circles is this much, but space between these two circles is too much. So in that more space you can make another circle, then here you can make another circle. What you clearly see is that the space between these two circles is this much, but space between Next one is more. If you see this structure clearly, just observe it from this point of view. You can directly see that one kind of circle is this, another kind of circle is this, and this is the third kind of circle. So there are three kind of circle here. You can directly see it. Again, look at it. One kind of circle, two kind of circle, and three kind of circle. So value of P is 3. Here you can see only one kind of circle is there because there is uniform space between the circles. What about this one? Here also you can see that there is uniform space between the circles. These are spreading out. So uniform space is there. So value of P is 1. Here also directly you can see one kind of circle, two kind of circle, and three kind of circle. Because the space is not uniform. So value of P is 3 here. I know this is a bit frustrating to you, or you might seem like that, sir, what kind of way you are telling, but it is what it is. This is how this topic can be studied. If I tell you that, like, or you can see is that, like, there will be 1 minima, 2 minima, and 3 minima. If number of minima are 3, the value of P is 3. 1 minima, 2 minima, and 3 minima. Value of P is 3. Only 1 minima is there. Only 1 minima is there. That's it. But now some people will have the doubt, sir, is this minima? No, this is not minima because field lines are continuous. There is no gap in between. But here it was continuous till this point, then there is a gap. Continuous till this point, then there is a gap. And right in the middle as well, there is minima. So minima, minima, and minima. So T is 0, 3. Minima, 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 TM 0, 3. Only one minima, so 1. And how it is TE TM? So H field lines are made from dashed line here. So that means circles are made from H field. Here circles are made from E field. Circles are made from H field. Circles are made from E field. So this is T, this is TM, this is T, this is TM. And certainly if from a dot circles are being spread out, that means it is certainly the case of 0. N is equals to 0. And here what did we study? In this case what did we study? That here I will see that this is your cross section of circular waveguide. What I need to see is that number of half cycles. 4 by 2, 2. 6 by 2, 3. Number of half cycles I will see. Then I will see the type of circles. One circle, two circles are there. So 2. Right? Then in this case, what I need to see? Number of dots I need to see. 1, 2. So divided by 2, 1. 1, 2, 3, 4 divided by 2, 2. Here 1, 2, 3, 4, 5, 6 divided by 2, 3. Then how many gaps are there? So here there is only one kind of gap. So only one circle can pass. Only one kind of gap, only one circle can pass. But here there are two kind of gap. One gap and two gaps. So there are two kind of gaps. So two circle can pass. So this is also minima. This is also minima. So T 3 2. Is that clear to you? Well and good. So this is about our field patterns. Now what we need to see? Now we need to, so just revise it once again. Okay, just revise it once again and it will be all clear to you. So do not forget the field pattern for rectangular waveguide as well as for circular waveguide as well. Do not forget any of the field pattern. That how to recognize the field pattern, that should be crystal clear to you. Now we will see the questions. On waveguide parameters we will see the questions. So that we will see in this video only. So in the second half of this video we will see the questions. So I will take a pause because I need to change the slides. And only 4 to 5 questions are there which I will be showing you in just a minute. And then you can try the questions and proceed in this video. So roughly around 1 hour of work is left, and after that our circular waveguide will also be completed. Okay, yeah, thank you. Yeah, so let's start the assignment. So 6 questions are there. This is the first one. You can try on your own. This is the second one. This is the third one, fourth, fifth, and sixth. So these 6 questions are there which you can try on your own. Let's start with the first one. So a circular waveguide with radius 92.05 centimeter and electric field component in radial direction is given. So this component is given. So here they have written R. What do you understand by that? They have told that this is the component in radial direction. That means this is ERO component. They have shown their radius by R. They can show it by any variable. They can show it by R, they can show it by rho, they can show it by X. Generally, they will either show it by R or by rho. But generally, what we are showing? We are showing with rho. So, ERO expression they have given. So, let's do it on the next page. So, ERO expression they have given, and our ERO expression is E naught J1 2R cos n phi A phi, A row cap. I just replaced R with row. So here as well there will be 2 row. Okay, so now I need to find the mode first. So on two possibilities are there. It could be TE mode or it could be TM mode. If it is TE mode, that means electric field is transverse. That means HZS is existing. And here EZS could be non-zero. I need to turn on the charger once. Just a second. Yeah. So where were we? So if it is a TM mode, then EZS is non-existing. Sorry, EZS is existing. Then if I need to find the E row, then what will be your E row? E row will be minus gamma G upon H square del by del rho EZS. Now EZS is a function of Jn rho and cos n phi. And now the differentiation is done with respect to rho. That means this will be a function of Jn dash rho and cos n phi. Jn dash rho and cos n phi. But is it a function of Jn dash? No, this is a function of J1. So that means it is not transfer magnetic mode. Did you understand this point? Certainly this is not transfer magnetic mode, it is transfer electric mode only. So let's check that out. So for transfer electric mode, I need to check my E row. So what will be my E row? HZS is non-zero. So minus gamma G upon H square, that factor I can ignore. Then minus J omega mu upon Kc square d by d phi HZS would come. That means this will be a function of, and here rho will also come since d phi never comes alone, so rho d phi. So now this will be a function of HZS is a function of Jn rho and cos phi only. So now if you do the differentiation with respect to phi, then it will be a function of Jn rho and sin n phi. So is it correct? Yes. Wait a second. Yeah, there should be sin, no? Here I have written cos. There should be sin phi. In the question it was given that was sin phi. So yeah, it is a function of Jn rho and sin phi. Jn rho and sin phi. So yes, which mode it is? It is a TE mode. So this mode is correct. So there is TE mode. Now from here what do I see? The n value I can see. Because our general expression is E naught Jn Kc rho sin n phi. So n value I can see that is 1. Here n value is equals to 1. But what is the value of P? It is TE mode, that means it is TE and P mode. But what is the value of P? So that P value I need to determine. So what all information is given here? The value of Kc. The value of Kc is 2. The value of Kc is 2. Now what this is equals to? Kc. Kc is equals to x dash np by A. X dash np by A. Why is that so? Because for TE mode, Kc is equals to x dash np by A. Right? So from here, what is the value of x dash np? That is 2 into A. What is the value of A? 0.9205. 0.9205. Because this is in centimeter, but I need to write the SI unit. So I will write in meter only. So what do you get? 0.9205. 0.9205 into 2. So 1.841. There you go. What did you get to know here is that my x dash np is my x dash np is 1.841. That means n value is equals to 1 and p value is equals to 1. That means which mode it is? It is your TE11 mode. Did you understand how to determine the mode now? It was a very good question. First we got to know whether it is TE or TM. Once we are sure that it is TE, then we came to the NP value. So N value I can directly see it is 1 only. But for P value, I need to see this Kc value. Kc is equals to 2. So x dash np by A is equals to 2. So x dash np is 2 into 0.925. Now this value I remember. This value this value need not necessary to be there in the question, because this I remember. So this value you get for n equals to 1 and p equals to 1. So this is your TE11 mode. There you go. Right? Because your x-11 is equals to 1.841. So this is your TE11 mode. Now mode is clear. What you need to find now? FC. So what is the value of FC? FC is 8.8 gigahertz divided by A. Right? In centimeter. A in centimeter. So 8.8 gigahertz divided by A. 92.05. So what is the answer you are getting? 8.8 gigahertz divided by 92.05. So 95.6 megahertz. 95.6 megahertz. This is the FC value you are getting. What else they are asking? Lambda C. So lambda C is Vp by Fc, which is 3 into 10 to the power 8. Here I need to assume it as air field only. Okay. Here it should be given that it is air field. Or an air field rectangular wave for circular waveguide. So 3 into 10 to the power 8 divided by 95.6 into 10 to the power 6, right? So 300 divided by 95.6, 300 divided by 95.6. So 3.13 meter is your lambda C. Next I need to find beta G. So beta G is beta under root. So certainly I need this factor, no? This factor I will be needing in beta G as well, neta G as well, VGG as well. So let's calculate this factor, which is cos theta T. So your cos theta T is 1 minus FC is 95.6. And what is your F? F is given in the question only. Operating frequency is given as 100 megahertz. That is 100. So let's calculate this. This is coming out to be 95.6 divided by 100 whole square minus 1 plus minus under root 0.293. 0.2933. So this factor is 0.2933. What is the value of beta? Beta is Vp by omega, right? Because Vp equals to omega by beta. So beta is omega by Vp. Okay, sorry. You know that Vp is equals to omega by beta, right? So beta is omega by Vp. Omega by Vp. Omega by Vp into 0.2933. So what is your omega? 2 pi into 100 megahertz. Here there is no omega c. It is omega only. 100 megahertz means 10 to the power 8 divided by Vp. 3 into 10 to the power 8 into 0.2933. So what that is equivalent to? So from here, what is the value of beta G you are getting? So this calculation we can do. So 0.2933 into 2 into pi divided by 3. So 0.61 radian per meter. So this is your beta G. Right? Is that clear to you? What else we need to find? Neta G. Neta G. Which mode it is? TE mode. Which mode it is? It is TE mode. Right? It is your TE11 mode. So it is your TE mode. So what would be the answer? For team, you need to stand by that. Otherwise, it would be neta divided by cos theta T. So that would be 120 pi divided by 0.2933. 120 into pi divided by 0.2933. So what you are getting? 1.285 kilo ohm. This is a random question designed by me only, so that's why values are pretty random here. Like this much high value of neta you will not get. Like lambda will be, there is very high chance that it will be in centimeter only. The cutoff wavelength will be in centimeter only, but here we are getting in meter. So these are very random value. So this value, this is your neta G. What about VGG now? What about VGG? So VGG would be VP into cos theta t. So what is my VP? 3 into 10 to the power 8 into 0.2933. So your VGG is 3 into 0.2933. So 0.88 into 10 to the power 8 meter per second. So I hope all these calculations are correct. FC value, this is correct. This is correct only. Omega by VP 2 pi by 3 and eta by cos theta t. Okay. So let's calculate this one again. Yeah, everything is fine. Okay. So yeah, this is how we need to calculate. The important thing was how to determine the mode. So these kind of questions can be asked in the examination. Well and good. Let's move to the next one. What is given in the language? The first zero for J1x and J1-x are at x equals to 3.83 and x equals to 1.84. What do you think what is given? J1x, 0 of J1x is given, that means they are talking about x and p. Now, what is the value of n? 1. Which 0 they are talking about? First 0. So, what is the value of p? 1. So, x11 is given as 3.83. What else they are asking? The first 0 of J1-x. J1-x. That means what they are talking about? X dash they are talking about. N value is 1. What is the value of p? First 0 they are talking about. So, x dash 11 is given. That is 1.84. So, in this kind of this kind of language can also be given. Like they can frame the question in terms of language. It's not necessary that they will write down that x and p is equals to 3.83 where n is equals to 1, p is equals to 1. So in this kind of language also they can write down. So you should have the ability of understanding that what is given. This is given, right? Cutoff wavelength you need to find. For TE11 mode. Actually for TE11 mode we directly remember the formula. But let's use these values. Let's use these values. So what I need to find? Lambda c for TE11 mode I need to find. It is also air field only. So what will be the formula? That would be Vp by Fc. Fc of TE11. So first I need to find Fc of TE11. So now people will say that sir I directly remember the formula. That would be 8.8 gigahertz divided by E. So that also you can apply, but if the values are given, let's use the values. Okay. If the values are given, let's use these values. And we don't know whether it is air field or not. So let's use the values now. So what will be the cutoff frequency? That I know that it would be Kc into Vp divided by 2 pi. Even if you forget this, what you are going to do? Kc square is equal to gamma g square omega c square mu epsilon. When you see this, what you will get to know? Kc into Vp divided by 2 pi. That is your Fc. So I told you, even if you forget this formula, then you can derive it within seconds. Now TE11 mode we are talking about. TE mode, that means electric field is transverse. That means H dash is existing. If H dash is existing, that means you need to do the differentiation. So X dash NP, that is X dash 11 divided by into Vp divided by A as well. So 2 pi A. So X dash 11 value is given 1.84 into Vp. Let's keep Vp as it is divided by 2 pi into A. A value is also given. Diameter is given. So what is this? This is 2A, right? Diameter is given. No? They did not give the radius. A is the radius. So 2A they have given. So what is the value of A? 7.66 divided by 2. So now what you can do? Lambda C will be Vp divided by 1.84 into Vp, because FCTE11 you need to write down, into pi into 7.66, right? Vp and divided by 1.84 into Vp, 2 and 2 get cancelled, pi into 7.66, right? So here Vp and Vp is also getting cancelled. So what is the answer you are getting? Pi into 7.66 divided by 1.84. So 13.07. Why it will be in centimeter? Because A is in centimeter only. You have put this A in centimeter only. So answer will be in centimeter only. So always remember that if you are putting centimeter here, this answer will also be in centimeter. So this is the answer. Very easy question, very straightforward. Let's see this question. The the broader width of rectangular waveguide is equal to the diameter of a circular waveguide. So rectangular waveguide, if I talk about, what is the broader width? We take that as A. Now in circular waveguide, what they are saying is equals to the diameter. So A is equals to D, they are saying. So usually what do I take as the radius? In circular in circular waveguide, our radius is A, right? This is our radius. But here if I am calling this as A, then I cannot call this as A as well. So I am calling the radius as R. So now my radius R is your radius of circular waveguide. Okay. Find the ratio of their dominant mode cutoff frequency. Okay. So what is the formula for TE10 mode? This is what we are talking about. We are talking about TE10 mode is there in rectangular waveguide. So we are talking about rectangular waveguide. So what is the formula? Vp by 2a. And here for circular waveguide, what is the formula of FC? Dominant mode is here TE11. What is the formula here? Here the formula is, if you don't remember, Kc into Vp divided by 2 pi. Usually I forget this formula. So that's why I always prefer doing this calculation in the examination. So from here I can get the clear idea, Kc into Vp divided by 2 pi. Right? So that would be x dash np, that means x dash 11 into Vp divided by 2 pi. So what is the value of x dash 11? Let's divided by 2 pi into a as well. And here a is not there, here it is r. So here a is equals to d, or you can say a is equals to 2r. Right? So what is the value of x dash 11? That is 1.841, which I usually remember, into Vp divided by 2 pi. And what is the value of r? R is a by 2. Right? Because a is equals to 2r, diameter is equal. So a is equals to 2r, r value is a by 2. So here a by 2. So what we are getting here? So here you are getting Vp by 2a. And here you are getting Vp by, so 2 and 2 get cancelled. This is pi upon 1.841. Or let's keep it like this only. What I mean to say is that 1.841 Vp divided by pi a. Here it is Vp by 2a. Right? So what I need to calculate? I need to calculate the ratio. Okay. Page is there. So ratio I need to calculate FCTE10 divided by FCTE11. So Vp by 2a into 1.841 Vp divided by pi a. So a and a get cancelled, this and this get cancelled. So what is the answer you are getting? Pi divided by 2 divided by 1.841, 0.85. So 0.85. This is your answer. Should be very easy for you. Like these kind of questions you should be so able to solve on your own. Right? So here I just put the values and then I solved it. That's it. So cutoff frequency value I need to put 1.841, that I usually remember it, because it might happen that they don't give this value in the examination. Then R value I put, then simply I took the ratio, nothing else. Let's see the next one. Air filled waveguide with radius 2 cm carry energy at 10 GHz. So F value is given. F value is given, that is 10 GHz. And radius is 2 centimeter. So A value is 2 centimeter. You need to find you need to find all possible propagating modes for TE and TM. All propagating mode. So for propagation, for propagation, what is the condition? That F should be greater than FC. F should be greater than FC. Your frequency should be, this 10 gigahertz should be greater than FC. Or I can write down that your FC should be less than F. Because F value I am already having, 10 giga value I am already having. Now FC value is different for TE mode and TM mode. So let's first solve for TE mode. So for TE mode, what is the value of FC? That is X dash NP into Vp divided by 2 pi A should be less than F. So your X dash NP, here Vp is, you already know that is constant. A value, you already know that is 2 centimeter. 2 pi value you already know. Only thing that you don't know is X dash NP. So let's take X dash NP here. So X dash NP should be less than F into 2 pi A divided by F into 2 pi A divided by Vp. Ten gigahertz, no? Yeah. So this I can write down as 10 to the power 10 into 2 pi into 2 into 10 to the power minus 2. 2 centimeter. Value of A is 2 centimeter. Divided by Vp. What is Vp? 3 into 10 to the power 8. So this is 10 to the power 8. This is getting cancelled. So 4 pi by 3. So X dash NP should be less than 4 pi by 3. Pi into 4 divided by 3. So 4.188. So your X dash NP value should be 4.188. So for which combination of N and P, for which combination of N and P, your X dash NP is less than 4.188, all those modes will be propagating. In case of TE mode, in case of TE mode. So table will be given here. Table will be given. Table will be given. Now in the table you can check that for which values of X and N and P. One thing I know that TE11 will always be propagating because X dash NP we require 1.841. So that will be certainly propagating. What else will be propagating? You can see TE01 and TE21. TE01 and TE21. So this is about TE mode. This is how you can check. So you just need to find what is the limit of X dash NP, then use the table and then you can tell which all modes will be propagating. So this is about TE. Now let's calculate about TM. Now talking about TM modes. So your FC should be less than F. What is your FC? XNP into Vp divided by 2 pi A should be less than 10 gigahertz, or you can say 10 to the power 10. So XNP should be less than XNP should be less than 10 to the power 10 into 2 pi into A is 2 into 10 to the power minus 2 divided by Vp. What is that? 3 into 10 to the power 8. So you are getting the same expression, right? This and this and this is getting cancelled. 4 pi by 3. So what should be XNP should be less than 4.188, right? So from here table will be given and you will get to know that only two modes are propagating, TM01 and TM11. So table will be certainly given in the examination if they are asking these kind of questions, or they will give the curve. What I feel is that most probably they will give the curve because they want you to understand the curve, and in our theory we have seen the curve as well, right? Okay, let's move to the next question. For circular waveguide, the lowest cutoff frequency is 10 gigahertz. What does this mean? The cutoff frequency for TE11 mode is given, that is 10 gigahertz. What they are asking? Just a second. Yeah, so what they are asking, find the lowest possible cutoff frequency for TM mode. So FC TE11 that is 10 gigahertz, that is given. and lowest possible cutoff frequency for TM mode. So first write down the cutoff frequency for TM mode. What is that? XNP into VP divided by 2 pi A. So lowest cutoff frequency you need, that means you need the value of XNP to be minimum. And what is the minimum value? Can you tell me? What is the minimum value of XNP? Do you remember? You should remember it, right? You get it for X01 and that is 2.401, or you can say 2.4 only. Just remember 2.4, or it was 2.403 or 1, I don't remember. Let's just say 2.401. Do you remember this point? So what you are actually calculating? You are calculating TM01, and what is that? 2.401 into VP divided by 2 pi. This is what you are calculating. And what is given? What is your FCTE11? That is your X dash NP, or you can say X dash 11 into VP, X dash 11 into VP divided by 2 pi. So what is your X dash 11? 1.841 or 1.841 divided by 2 pi A into Vp, and that is given as 10 gigahertz. So from here what you can see is that Vp upon 2 pi A, that is given as 10 giga into Vp upon 2 pi A is given as 10 giga divided by 1.841. Vp upon 2 pi A is 10 giga divided by 1.841. So here what do I see? 2.401. Now Vp upon 2 pi A, what is this value? 10 giga upon 1.841. So smartly I am avoiding the calculations. Did you understand this point? Here, like what people would have done, they would have put the value of Vp, then they would have find the value of A, then again they would put the value of Vp here, then find the value of A. So that will be needless calculation. Here I know that what I need to calculate, and this factor value I can get from here, because from here 10 divided by 1.841. So these two values I asked you to remember, this value and this 1.841. Two values I always ask you to remember, because they are the minimum. The minimum value of X and P is 2.401, and that will occur for n equals to 0, P equals to 1. And the minimum value of X dash and P is 1.841, and that will occur for n equals to 1 and P equals to 1. So if you solve it, what you are going to get is that 13.2 gigahertz. So this is your answer. Well and good. Let's move to the last question. So for a rectangular waveguide, A is equals to 2B. ठीक है, okay. The cutoff frequency of a rectangular waveguide, the cutoff frequency, the minimum cutoff frequency of a rectangular waveguide and a circular waveguide are same. Then find the ratio of their cross section area. So what I need to find? I need to find the ratio. So what ratio it will be? Rectangular waveguide divided by circular waveguide. This is what I am finding. Ratio of their cross section area. So what will be the ratio of their cross section area? What will be the ratio of what will be the cross section area of a rectangular waveguide? Cross section area, that would be A into B, because this is my rectangular waveguide and this is the cross section of my circular waveguide. So here this is my A and this is my B, which is A by 2. So can I write down here A square by 2 divided by, what about this one? This has a radius of R, let's just say. And what they are saying, okay, R value only I will assume. This has a radius of R. This has a radius of R. So what is the area? Pi R square. So what do you get? 2 by pi A by R square. Now what do you need? You need the ratio of A by R. This is your target. What is your target? Get A by R. So for that, what they have given, the minimum cutoff frequency are same. So FC TE 10 is equals to FC TE 11. But this is for rectangular waveguide and this is for circular waveguide. What is this rectangular waveguide? Vp by 2a. Vp by 2a. What about this? This will be your 1.841 into Vp divided by 2 pi r, right? So Vp get cancelled. What I need to find? A by r. Your A by r would be 2 and 2 also get cancelled. So A over here, pi by 1.841. So what is the ratio now? So ratio is 2 by pi into pi by 1.841 whole square. Pi by 1.841 whole square into 2 divided by pi. Vp by 2a 2 by pi by a by r you need to find a square by 2 pi r square. Okay, yeah, here there is an error, no? This would be 1 by 2 pi, right? 1 by 2 pi, no? This would be 1 by 2 pi. So here it would be 1 by 2 pi. 1 by 2 pi. So pi by 1.841 whole square divided by 2 divided by pi. 2.16. So like this ratio is coming out to be 0.46. This ratio is coming out to be 0.46, but they did not give that which ratio you need to calculate. So this is your rectangular waveguide divided by circular waveguide. If you need to calculate circular waveguide divided by rectangular waveguide, then that is coming out to be 1 upon 0.46, and that will be equivalent to 2.16. Okay. So both of the answer you can check, whichever the answer you like, you can pick any one. It will be mentioned in the examination that which ratio they are asking. Okay, so which ratio they are asking, that will be mentioned in the examination. So this is the way of solving this problem. Very easy, and now I hope you are comfortable with circular waveguide as well. So that's it about our waveguide chapter. Waveguide chapter is completed. Next we need to start studying about antennas. So now we will study about antennas. So do comment down how did you like the waveguide chapter. Okay, thank you very much.